Not yet.
We've got Chris Morrow and we've got Eric Baker.
Okay, so cool. And so they're what?
Chapter and regular.
Cool. Okay, it is now 9:30. We need to get started. I need to get closer to the mic. Is this? Okay, yeah. Okay. So good morning. This is V6OPS. If you think you're somewhere else, you're in the wrong place. 9:30 and all's well. So we need to move along. You see the note well slide up here. If you haven't run into a note well, you haven't been around the IETF very long. So note well. Takes a long time. Okay, so the agenda we have today.
I forgot my power here yesterday.
Huh?
It would be Mac.
Is this it? Well, it
is now.
The room monitor handed it to me. I can get mine out of my bag. So if you're looking for this one, okay. Okay, so be it. Come on in, guys. Have a seat. So this is the agenda that we have today. We've got, if you think of our slot today and Thursday as a total of 4.5 hours, we have 9 half-hour slots. We've actually got 10 talks. I'm expecting a couple of them to be relatively short. Mine will be among that. So I think we'll actually be good for time. So people speaking, you can plan on about half an hour, and if you need less, that is well accepted. We have one agenda bash, which is that John Brzezowski, the thing that he's working on with the IETF SSID is likely to happen in the imminent future very quickly. So he wants to speak first and have whatever discussion is going to.
Warren's making the get closer to the mic face again.
Huh?
Is it? Oh, okay.
John thinks it is. So okay, I'm going to move him in terms of speaker order. I'm going to move him up to the beginning just to get that out of the way. Does anybody else have any agenda bashing that you want to do? Jordy? Right. Right. You sent me the slides. I've got that on there. So, okay. Yeah, well, basically the last half hour, probably Thursday, is going to be the Jordy show. So it's whatever it is you're doing. So, okay. Anybody have anything else you want to talk about? Okay, fine.
It would make sense probably to have that document after the happy evolves presentation.
People can't hear you. Use the mic.
It makes sense probably to have that happy evolves thing after the happy evolves BIS document, maybe.
Okay, I can do that. Okay, but with that, I'm going to consider the agenda bashed. So now, actually, no, this is John. Where are you? Yeah. So here's the mic. Oh, speakers. This has been true the last couple of IETFs. You're supposed to stand inside this little tiny box, and stand on this postage stamp here, please. So.
Thank you.
Yeah.
I can just use this one.
Huh?
I'll just use this one.
Okay, that's fine. So let's see.
Ready for liftoff? Ready?
Go for it.
Okay. Good morning, everyone. John Brzezowski here. So I'll represent the other folks, the multitude of authors on the draft that Fred had up here. So basically the gist, there are no additional slides. Fred is generous enough to open up a web page to be the visual aid here for today. For those of you who have not read the draft, it's pretty simple. It's basically eating our own dog food. It is basically an incremental proposal that is based off of the experience that many of us who have written the draft have used in our own companies and environments to basically incrementally introduce V6 only with IPv4 support, right? So that's yeah, I think it's very important to make that clear. We seem to have, possibly, maybe missed that as part of the conversation thus far. So we're not, and I know we've had some conversations with people about an experiment that maybe Russ did a few years ago, where we turned off v4 entirely with, no help, i.e., no NAT64. That's not what's being proposed here. I mean, as much as I'd love to see that happen, someday, perhaps, in my lifetime or career or what have you, I think it'll be a while, maybe, depending on kind of environment you have. But at this stage of the game, we still need some help for v4. So the proposal that we put together is an incremental approach to introduce v6 only to the main SSID, right? So myself, Jim, Randy, Yari, when he was the IETF chair, Alyssa now. I think we've been having this conversation since at least Seoul, Jim, yeah? Seoul. Doc has been very generous, patient, tolerant, I guess maybe even a better word. We've made some preparations from, we've done our best to help make some preparations from a hardware point of view to make sure that we have production grade equipment that is, that we can stand behind as far as, offering a reliable v6 only environment that has NAT64 and DNS64. So the crux of this is this, right? If you look at this page here, and Fred, would you mind, I don't know if you don't have to do anything, it's fine. There are 43 devices connected to the NAT64 environment here at the IETF. There's more than 43 people here. There's probably more than 43 people in this room. Not heavily utilized, and if memory serves me, Jim will keep me honest, I think that number was 12 in Chicago-ish. Jim, there you go.
That's a real-time stat. So we happen to have 44 on right now.
Yep.
I don't have a final number on what the maximum was on that SSID, but it varies over time. It's usually under 50 or so.
Yep. Yeah, I think that's really what I was going after. Either way, I'm not going to split hairs with you, but it's low. Almost, yeah, very low. So, show of hands. Who here has deployed 1 million or more v6 only devices at work? 5 million. 10 million. 50 million. Righto. Okay, so and I said v6 only, right? So I have lots of devices that are v6 only. I'm not talking about the dual stack. I've excluded the broadband devices that are dual stack in when I raise my hand. So what's the deal, right? So it's good enough for us at work, but not good enough for 1,500 people at the IETF. I don't think so. That doesn't fly. That doesn't fly.
Not good enough.
Yeah, that doesn't fly, right? So. With that being said, that is the proposal. The proposal is basically to organize a kind of trial, so to speak, of this. This is not an experiment, right? So, I mean, I'll be perfectly honest with you. I mean, as much as I love to experiment with things, the intention here is not to for this to be an experiment. The proposal here is to basically get the ball rolling so that this is the permanent state of affairs, for the IETF network. So the SSID that Fred's probably connected to. Can you click on your Wi-Fi? Little doodad there.
Click on this thing.
Yeah.
Okay.
Bad Fred. Bad Fred. We have to put Fred in detention. He gets demerit. I love you, man. So that's the proposal, is to make that SSID by default v6 only with NAT64 and DNS64, right? So there's been a very lively discussion, and there's been a kind of a wide range of opinions, which we appreciate, respect, but either way, I think the idea here is that we'd like to move this forward, and we need some, and when we last discussed this with Yari and even Alyssa, the notion here is that the community really needs to chime in and decide what it is we intend to do here as far as the IETF network is concerned. So I'll pause there. I want to get my bulletproof vest on so that Jim can throw stuff at me, and then I will leave you alone.
Jim?
I just want to point out that every one of those SSIDs that are up there is v6 enabled. There's obviously the one that is truly v6 only. We've got NAT64, and then a number that have both v4 and v6. I don't think that the current state of situation in any way negatively impacts IPv6. I simply think that if you happen to be on IETF, you can use either v4 or v6. You can maintain an end-to-end model with no middleware boxes in the middle and provide full connectivity. in fact, actively breaking what we're referring to as the default SSID by putting something in the middle that could potentially introduce problems seems counter to the goal of ensuring that the primary network here allows people to get the work done that they need to get done. With the other options being available, I think that anybody who wants to use it, it's there. But forcing people, particularly people who are not V6 people, I mean, there are a lot of people that come to the IETF that their focus is entirely elsewhere, that they don't, this isn't something that they're focused on trying to do. So why make them?
Yep. If I may, Jen, hold on one second. So while I do respect your opinion, I do 100% disagree, and you know that, right? I do not agree, right? You know, with our experience over the past decade or more, one of the things that we find, I don't call it breaking it, right? I call it finding the bugs, right? Just yesterday, Jordy was, commented about something about OpenVPN or something. I mean, with just the push on the email list, we're finding things that really need to be fixed, right? There are people in this room, and I suspect, Marcus here from Microsoft will comment on this momentarily, that are relying on this for their enterprise environments, right? So, we won't agree, long story short. Jen.
Jen and Google. First of all, we've just seen that some people get connected to IETF SSID accidentally, while they probably really would like to be connected to NAT64 SSID, right? So I'm pretty sure we can get more users on this. And secondly, from experience of running V6 only networks, we did it at RIPE actually, right? And I've been using NAT64 SSID since my first IETF. And initially I had to switch back a couple of times, but those bugs been fixed. Those issues I reported been fixed. So I think if we are not going to eat our dog food and we believe we're going to do nothing to get V6 only working, we should just go home. We should not be here.
Should we roll back V6?
Oh yeah, well, wait, I don't want to run dual stack. It's too expensive.
Warren.
So it's just as easy for people to join NAT64 as it is for them to join the regular network. However, we see a lot of people are joining the IETF and IETF legacy. Okay, maybe you can ignore the IETF legacy, but there are way more people who joined IETF and IETF 2.4 only. Maybe that proves that, the food isn't that tasty. People are joining the IETF one for a reason. If they wanted NAT64, you click the other button. It's not hard.
Warren, it's kind of a lame, position, right? I mean, it's the default, right? When's the last time you clicked on it one time? 10 years ago, when it was the only SSID there was on NAT64, it's the default on your computer, dude, right? That's probably the main reason why everybody picks the IETF SSID, right? Perhaps.
Jordi Palet. I am sure nobody has any doubt that I am pro IPv6. I think that's clear enough for many years.
Show us your tattoo, man.
Okay. The point here is, what is the main goal of doing this, in addition to trying our own dog food? It's detecting broken applications. Is that the point?
It's making it so that it is 100% usable as the primary network connectivity for everybody and anybody, the 1,500 people-ish that are here, right?
Because the point I am trying to make in the mailing list yesterday is, I agree we should move on this. I don't think we should do that with an internet graph. I think this is a major step in our network that must be workable for everyone. I agree that it's not a problem if you can fall back to another SSID, which is dual stack. But if we want to detect as many as possible broken applications and things to help the developers or whatever to correct them, or at least to signal them, hey, this is not working, you should do something. Mm-hmm. I think it's much better to do in some automated way, and that's what I am proposing, okay? So if we have, instead of many times reporting, which require a lot of people doing some additional effort, and I am sure many will not do, it's human nature, because when something that is critical for you doesn't work, you switch to the secondary SSID and you don't detect anything more that is broken in your laptop, right? That's going to happen. Why not going to a way which detects for us? Yes, we need to do maybe some small development, some script, something that help us to automatically detect as many as possible broken things. That's the basic point I am doing. I am not saying not do that, just do that in a different way, which facilitate the work. One question, maybe for Jim actually, how many reports you are getting in recent IETFs for broken things in the NAT64 network? Maybe that gives an idea of how much people, even if it's a small number, is actually contributing to that.
Jim, hold on one second. George, go ahead. No, go ahead. Yeah, go ahead. Yeah.
No. If you want to answer.
Please, yes, please. Yes, please.
Oh, so the answer is currently we have 2 tickets open, one from you and one from you.
Recent meetings, not just,
right. And just actually to address that, I just wanted to mention it. Because of the fact that we're starting to get some issues on the NAT64, we're collecting them. We're going to make a wiki page so that everybody can see what the issues are that are outstanding, and we'll feed that back to A10, whose hardware we're using.
Yep.
And hopefully we can actually fix some of the issues.
Yeah. So Jordy, hold on, don't go anywhere yet. So the two things. So you have to believe. I mean, so we should talk to you about the comments you're making, because it's what you're saying verbally didn't come through to me on email, right? That's not the same way it came through. So let's talk separately and then see, let's kind of harvest some of those ideas. The one thing you also have to know about me, right, dude, I don't really write internet drafts, right? It's kind of a pain in the ass, right? I didn't write this because I really wanted to, right? I wrote it because when we sat down with Jim and the rest of the NOC guys, they're like, hey, can we get some documentation together to kind of at least jumpstart this process, right? If I could have skipped it, dude, I would have, man. I would have handed off some PowerPoints and said, hey, let's do this, right? So, I mean, we didn't want to do overkill with the draft, but it felt like a good place to start to communicate what the design goals are, some of the details. Yeah, I would have skipped it all together, man, honestly.
Okay, I'm going to cap the mic. We've been 7 minutes with Jordy, and I'm just counting the people at the mic. So I'm capping the mic line.
Lorenzo
Clutie. So I sort of disagree with you, Jim. I think so. This deployment model is the future, right? It is the only sustainable v6 only deployment model that I've seen so far, because the dual stack model is fundamentally operationally more expensive. This is what the internet is going to look like. Now, the only question is, do we want to live in the future or do we want to live in the past? If we want to live in the past, let's turn off 802.1x, let's turn off v6, let's stay v4 only, let's go back to 1999, and that's the IETF network. Minimum lowest common denominator. That's safe, right? We know that there are devices at this conference with v6 bugs that don't support 802.1x. We don't support those on the main SSID. We say if you have one of these, insert adjective here, devices, then the legacy network is for you. And I think we should do the same here at some point. Maybe it's not today. If we know that there are known hardware bugs in our implementation, we can't actually ship it as the default. But fear of client breakage, when all we need to do is send an announcement and say, hey, if you see a bug, A, report it, B, use one of these other ones. That's not a high bar for our users to jump through.
Jim.
It's not mine personally. There are a bunch of us that are working on this. But I think the key that we need to all think about is, what is the objective of the network that we build here? Is the objective to facilitate people being able to successfully work, or is the objective to support a specific ideology or a specific idea moving forward? And I think that that's definitely something we want to hear from the community.
Yep.
The view from the NOC is that we want to make sure that people have the most successful use of the network, period. And we want to make sure that if you want to do some other things, there are capabilities that are built into the network, but that fundamentally it's whatever is going to make it work most successfully.
Yep.
So I guess that's really, we've got to answer that before we move forward.
Yep. Two things before David goes. So the we here is the 1,200 people who are here, right? I think I agree with you, right? Like, this is not Jim, so like let's not like reverse throw fruit at Jim, right? Because this isn't, Jim. This is a community decision that we all need to make, right? And I'll get to that towards the end of the kind of the talk here. And to make one comment to something you just said, we don't want to kind of strand anybody by any stretch of the imagination, which is why we deliberately built into the proposal always having a fallback SSID that people can go to, right? I think Jen, when we were kind of having the email exchanges as we were writing the draft, it was actually a very useful proposal to have like a IETF insert number here, fallback, SSID every time, to basically make so that people had to deliberately pick the new number, SSID, right? So we've built that in, and we're sensitive that every single one of us who's written in the document have production experience deploying to very large population customers. So we know what it takes to not piss the customers off and not get fired.
Just one more point on the, you had mentioned, everybody's on IETF because they have it in their cache from a long time ago. The IETF Legacy 99 was an interesting experiment for us to see if people actually really wanted to be on the legacy network, and clearly a lot of people did because they had to choose that. So I'm not sure if we truly have people that are on these just because it's cached for them.
Interesting. David.
David Skenazy, Apple. I wanted to add a point on Doherty's comment about automating issue detection. I totally agree. If we had a way to do that, that would be obviously better. Asking people to report failures is a pain. No argument there. However, it's something we tried to do for a long time. This year, or actually last year now, we deployed V6 only for some iPhones without for 6.4xlat. So what that means is that if an app isn't written properly, it won't work. And we tried to build something into the OS to automatically detect that and say, okay, for those really rare cases, we would tell the cell phone network to actually give us V4 so the user isn't stranded. And it turns out that's an incredibly hard problem. There's no actual good way, even if you control the entire software of the operating system. So on a network like this, even though it's not ideal, asking people or having them join this network is a great way to see what's broken. In your case, your OpenVPN config file was wrong. Being able to figure out from some of the logs and some of the boxes on the network that that was the case is just completely impossible. And now it was an experiment that took 5 minutes, and you fixed your config file, and you were one step further to having software that works.
What I am suggesting is not actually detecting what is the failure, because obviously in this case, in the OpenVPN example, it was some people that helped it. But for example, I detected also Microsoft Office in Apple having the same problem, but I tried to investigate it and I don't have the source code or whatever to try to find it. So I am not telling, let's do that. I am telling just to dump some packets for every CLAT communication, which means that those applications that are making those packages flows are broken.
But
in NAT64.
They're not, though. There are a lot of applications that will use the CLAT if it's there, but will still work on NAT64. And that's what we've seen. I have operational experience for this. We tried that because that was a natural idea. And it turned out that so many applications would try both, and they would flip the detection. So that's why that's sadly not a viable solution.
I really wish that everybody has the capability to go to the NAT64 and actually report every broken thing. But my experience, because many people here needs the network to keep working, we know it. So my experience is that when you are in that situation, you switch to the legacy or whatever SSID. That's my experience. Actually, I needed to do.
But that's fine, and that's the whole point. Yep. We learned something. You switch back to legacy, you're still getting work done.
Okay, you detect
one at a time, guys. One at a time.
Yeah, you detected that something was broken, and now you're still getting work done. So yes, maybe you lost 2 minutes, but now we know that there, and we're probably going to open a support ticket against Microsoft Word.
Yep. Michael?
Michael Richardson, I'm very supportive, and I want to point out that the number went from 43 to 61 while you were talking.
Bravo.
And I did push the buttons too, and there you go. I'm supportive of moving to this, and I think we should have a plan. And I'm sorry I didn't read the draft, but and I know there was plans of doing it somewhat incrementally. So my question actually for Jim is, what amount of effort would it take to selectively turn off the IETF network in certain working group sessions like this one? Would that actually be a big deal, a small deal? It would cause people to try.
We'd have to plan in advance because the way that things are grouped require reboots. But it's theoretically possible that in a certain region, obviously there aren't APs associated with working groups. They're associated with physical locations, and they bleed between. But we could work something like that out. Actually, one of the key things I want to mention is that we aren't opposed in general to doing changes. That's certainly not the case. We just want to make sure that whatever changes we do make are planned and actually have a rollout schedule so that we can do things in a sane way once we've agreed where we're going.
Well, so I think you should repeat the thing of Legacy 99, party like it's Legacy 99, right? But of maybe deciding to change the IETF ESSID with a number, so people have to actively pick it, and that was in the thing, and leave the other ones the same. Maybe IETF NAT64 is the only one that doesn't change, and that's my thought. So incrementally try and grow that 70, I think, and maybe when it's at 200 or 300, that maybe it's time to then to think about it, and maybe that's only 3 IETFs from now or something like that.
There's a thought on the table, and I realize I've sort of jumped the line here, but there's a thought on the table to eliminate the IETF SSID.
Eliminate it, yeah.
Rename
so that's
it,
what I thought, just turn it off, yeah.
Well,
eliminate, turn it off.
Rename it from IETF to IETF dual stack or something along those lines. And there won't be an IETF SSID. You'll choose one of the others. It happens to be NAT64, happens to be dual stack. You made a choice. Okay. That would have the effect of making everyone make a choice, and then they can be where they want to be. But that's a proposal that's on the table. We're playing around with it.
I like it.
Jelinkova, first of all, ETF legacy just proves that if something does not work for you on default SSID, people fall into another SSID, and they're happy and sky did not fall, right? So I think it looks like it's feasible for people to switch SSID if they could not. I personally volunteer to help people with changing SSID on their laptops if they need help. And second point, do we have, we are saying that we are probably not ready. All those devices could not join V6 only SSID. What would be the criteria when we believe we are ready? Can we get something defined?
Warren.
So Warren Kumari. So people in this group fairly clearly have a sort of pro V6 view, right? If you poke the average person who comes to V6, unsurprisingly, they're interested in V6. It's not clear that the rest of the community has the same set of views, right? When we asked people before, what's your purpose for the network? A large amount of them said, I just want to get stuff done. So we shouldn't take the views only within this room as being representative of the whole community. If we were, it would be a fairly clear choice. Making the change is trivial to do, right? It's just, is that what the community itself wants, or is that what this group of the community wants?
Would you say the IAB is a broader representation of the IETF at large?
No, I'd say the fact that we do surveys and get some feedback is a good representation of the IETF at large. If we do a survey and say, would you like a V6, NAT64 to be your primary network? And the majority of people say yes, then that's an obvious solution.
Should I have done that when I launched broadband with V6? Come on, Warren. Dude, don't run away.
Yeah, we did cap the mic at one point.
Yeah, but I mean, you're asking a question, right? Okay, Joel Yegley. When I make a decision as a business, like I'm doing that on behalf of my customers and my business intentions, right? You're not doing that for this enterprise.
I don't get it.
Yeah, well, you don't have to.
I kind of do.
No. Like,
yeah.
When we go out and we make commercial decisions, we do that because we think they're in the best interests of our consumers and our shareholders. Right?
Yep.
We're not individually in the position to do that for this organization. So the rhetorical question of, do I do something that I believe is good for my business or not, is a separate one than what happens when we come together as a community and we ask for consensus.
And that's why we pose this question to the community.
Yes. So
exactly.
It is not the same activity that you engage in or that I engage in when we make business decisions.
Okay. Okay. So, final comments. So the ask of you guys, give this a try. Please join us. We're having some discussions with Jim and others at the IETF to decide what to do for basically the rest of this IETF meeting as a community. So, give it a go, read the draft, send email on the list. Today would be good, if you don't mind. Thank you.
Okay. So what is the WPA credential for the NAT64?
It's the same as your PIN code for your bank account, Fred.
Probably. Okay, so with that, thank you very much. Run diagnostics. Okay, tell me about that, John. You know what I'm going to do? So, okay. So with that, Marcus, can I put you on the spot?
Morning. This is my first IETF, so it's good to see some friendly faces. My name is Marcus Keane. I work in the group in Microsoft that manages the internal network. And by that I mean the corporate network as opposed to Azure or online properties such as Microsoft.com. So this morning I'm going to talk to you about IPv6 and IPv6 only in an enterprise. I'll start as sort of having a brief discussion and overview of the network just to sort of give some context. We'll have a look at why IPv6 only. I said if that's fairly germane given the last couple of minutes. Have a look at our current status and what our plans are. A brief look at some issues we've had, and then we'll conclude with I think what is going to be one of the major challenges for enterprises and some potential solutions for that. So, as might be expected, it's a fairly large network. The main campus in Redmond, which is just outside Seattle in the USA, is over 100 buildings. And the network generally is organized into three regions outside of that, as most enterprises are with Europe, North America, and Asia. So one thing you'll notice here is that the number of on-premise data centers has dropped dramatically, and from 11 down to 4. So clearly the implication of that is that a lot of the internal properties have moved from those data centers out into the cloud. So that makes a statement. It also means that some of our traffic patterns have changed, and it gives us some new challenges. Most of the tail site connectivity is provided through layer 3 VPNs provided by different carriers in each of the regions. So that brings with it its own challenges. A lot of locations, almost 800 locations, which is again, things move slowly at that scale, and about sort of 1.2 million devices generally seen on the network on a day-to-day basis. In terms of IPv6, dual stack is enabled throughout the whole corporate network, with the exceptions of some labs and so forth, where we have to move a little bit more slowly for fear of breaking things where we have different hardware that may not handle it. So IPv6 only, why? So I think within our own sort of environment here, it seems to be axiomatic that IPv6 only is a better thing. Personally, I think it is. So I think it's going to be worthwhile spending a couple of minutes just explaining sort of why it is, at least for us. The headline view there is exhaustion of IPv4 space, which everyone is aware of that, but particularly for 1918 space for us. So between ourselves and Azure and some acquisitions, not only have we exhausted 1918 space, that we have some overlaps. So that sort of leads to some unpleasant but necessary sort of NAT solutions, which are complicated. But I think going back to a point that I think Lorenzo made earlier on, this is the compelling thing for us. The long-term view has got to be getting rid of dual stack. Dual stack is hard, and it's very complicated and it's very expensive for many reasons. I mean, the obvious ones are you've got to maintain 2 IGPs, you've got to maintain, 2 sets of ACLs, 2 sets of firewall policies, etc. But the last one there is a sort of a hidden cost, but it's very real, and that's the support element of it. Supporting two protocols is very difficult, and sort of there's a sort of a reflexive move to sort of disable IPv6 if there are problems, and unfortunately that fixes things, but it's not the long-term solution. I mean, we've overcome that now. That's certainly not what we do, but it certainly can increase the time to sort of recovery for client support. IoT demands, I mean, that's been well covered in other forums. But we're no different, and with clocks and cameras and so forth. So, and obviously trying to sort of address those out of IPv4 is ridiculous. So where we are, so we have a test bed in the IT buildings in Seattle. That was put in a few years ago by Justine Vick, who's in the room. So that encompasses the guest network and some wired and wireless segments. So it's opt-in at this point, but we have plans to make it sort of the default access method. We have some test segments in Europe, North America, and Redmond campus for supporting the product groups, and they're working pretty well. So our existing plans are to expand that offering to, again, more product groups and more regions, Asia in particular. Again, because I think there's a lot we can learn from that. And then we will be piloting, dual stack and sort of IPv6 only. And I think this is probably, I hadn't really thought about this bit of it, but I think it's worth me, making a couple of statements here. I think from the previous discussion, speaking personally as a network operator, I think it, from the last discussion, I think it is important to try push ahead with V6 only, because if there is a fallback, I mean, that obviously that is great. But I think it's important, and a number of people have said this, is to find out what the issues are, because I'm sure there are automated ways of discovering issues with V6 only, but really it's quite complicated, because if some services are half built or available on V6 and some are only available on V4, there are some interesting interactions there that are hard to detect in a programmatic way. And as long as the fallback is reasonably quick, I'm just speaking personally now, that I think it's a good thing if users discover issues and they report them back. Then I think that we're one step closer to finding out what how to do this in a large scale way. That's just my opinion. So in sum, I would support with a fallback moving towards V6 only. Anything slowing us down? I think guest network deployment. I think anyone who's heard me speak about this before will have noticed that there's a signal thing missing here with guest network. But we have talked about this before, of enabling V6 only on the guest network, and the thinking behind that was that the traffic profile would be very simple, and it's just email, web, etc. Unfortunately, it's also VPN. So this is an industry-wide problem. A colleague of ours, Todd Thorson, spoke at the Facebook conference recently, and only 2 of the attendees could actually connect to their VPN over the V6 only network. So that's a problem. There's no doubt about it. But I think but what has it done is it engendered a lot of research and a lot of people looking into this. So I think that's where we're going. That's what we're doing currently. Network platform features. This has been covered in quite a few forums, and RDNSS on the routers is one that we're currently dealing with, and wireless controller security features. So I mean, this is, like I said, this has been covered, and I'm happy to talk about this later on or over a beer or whatever. So new building configuration. This is kind of an interesting one for us. In olden days, the segments were much more homogeneous, and that you might have, say, finance or HR on a single segment. And so it was much easier to determine sort of what sort of applications might be running on that segment. and therefore what you're likely to break if you move it to V6 only. And along with other sort of enterprises, we now have this sort of new world of work, as they call it, where you have much more heterogeneous segments, where again you might have engineering and finance and HR all in the same segment. So it makes it much more difficult to determine what is actually running on this. Clearly, we have things like NetFlow, which will tell us sort of what, in terms of top talkers, and that will give us, a good view into what mostly what is going on. But the big problem, I think, is the long tail. So this is where you might break something that is used infrequently or has a very low traffic pattern. But unfortunately, the squeaks might be quite loud if you break it. So it takes a lot more time, and we have, it'll require a lot better sort of telemetry, which we're working on at the moment. Multi-homing complexity. This is sort of, this exists at a larger level, but also really for us, the big problem here is going to be mostly at tail sites. And so this sort of leads on to one of our sort of corporate strategies, which is internet first. And as the name describes, it's basically having local egress at a branch office. And there are many reasons for that, amongst them cost, performance, and obviously it implies sort of, when you do get local egress, that you have some address space from the ISP. So it brings up the question, now that you have potentially two prefixes sitting on the segment, how does that work? From a routing point of view, it's in theory quite straightforward. You can use such techniques as sort of policy-based routing, which operationally is very difficult. And I know obviously that it's been around for a long time, but it's one of these things that will it make sense at 2 o'clock in the morning, and sometimes it doesn't. Source address dependent routing is that there's a lot of work going on at the moment looking into this, and this becomes interesting because it's certainly much better because it gives you a lot more flexibility. But furthermore, if it's in the RIB and in the FIB, it's operationally much more supportable. But there's still the issue of the source selection with multiple prefixes on the segment. And obviously the source selection, 6724, it will produce a result that is correct, but it may not be the result that you want. So this is kind of an example of what I'm talking about, and this is fairly real. So you have a typical scenario here where you have a router, a branch office router, and it's been addressed out of the corporate /32, and it has local internet egress from the ISP, and it's been assigned out of 48 out of that. So if it wants to connect to a device in corporate network which is addressed out of a different 32, then what is it going to do? So in this case, again, due to longest match, what it will do is it will use the ISP's /4 or 64 in this case to connect to the corporate network in North America. Equally, if the host wants to get to something in Azure, it will use, in closest, because the Azure /32 is adjacent to the corporate 32, so it will use that as a source. So it's correct, but it's not really not what we want. So really, there are a couple of options that we could use to sort of overcome this. And I'm sort of enumerating this just because it actually is, it is a sort of an option with NAT66. It may be distasteful, but it actually would overcome the issue. There's a possibility of using the ISP space exclusively, in which case that would certainly work. But the problem is that now that you need to ingest that 48 into your corporate routing tables, and that is distasteful. And sort of, again, that becomes operationally difficult. So we wouldn't want to do that. You could use your own IP space exclusively, but it sort of implies direct DBGP with a public AS. Looking back at this here, it looks as if there is a direct connection with the ISP and with the corporate network. And in some cases there is that, but in other cases, a lot of cases, as I mentioned earlier on, with the tail site connectivity is through a layer 3 VPN. And what that would mean is we'd have a private AS doing eBGP with the carrier, and then we would ride the sort of Layer 3 VPN back to the CUB site. So if you had an internet egress there, you wouldn't. You would have to do peering, with your private AS. I mean, clearly you could do local AS, but local AS is kind of hacky. We could use, so I think, and I should have put this as a sort of larger point in the bullet, but I think, it feels that from an operator point of view, using your own iSpace and the ISP space seems like the right thing if you could get it to do what you want. So, as is obvious, the crux of the problem is that you really have an intersection of two routing domains on the segment, and what you want is to be able to sort of link the destination prefixes with source prefixes. So at a very minimum, you have some requirements, and they've been sort of amply documented in the PA multi-homing draft there. And really, what at a very minimum, what you're going to need is multiple RAs and sent from multiple linked local addresses. And so what this can give rise to is the use of Rule 5.5 in 6724. So that's a potential. But I think also there's some important stuff described in Jen's draft there on conditional RAs. I think on really the interaction between sort of ND modules and the routers and the RIB. I think that this is inevitable. I mean, whatever we do, this is going to have to happen, I think. I think you can think it's analogous to tracking in using other technologies, but I think this is going to be important. But I think, while you can get things to work here, I think you're limited in a certain way, particularly if you have, say, remote border routers advertising, egress from multiple points. That becomes a little bit trickier. So I think a more sophisticated solution is required, and provisioning domains fit that bill in my view. So provisioning domains, and I apologize in advance. So if any of you were in Sixman yesterday, Pierre presented this in talking about PVDs. But I think it's important, so I'll cover it again. Really, what it is it's it formalizes the notion that you have different routing domains or administrative domains reachable on the same segment, and then it allows the client to determine what parameters are attached to each of those domains, and make somewhat of an intelligent decision. Looking back at I guess the drawing earlier on and what the topology was, that from an enterprise point of view, the useful bits for us would be what prefixes are reachable through the domain, what sources to use, and what DNS zones are reachable through the domain. So as I say, it's described in detail in that draft. It's well worth reading. Much of the functionality, again, will also require functionality that is described in the PA multi-homing draft, the multiple RAs and Rule 5.5, etc. So this is a sort of an illustration of how this might fix the problem that we have from earlier. Again, we have the same situation, the same 48's being announced, but you also have two RAs. And in this case, we can signal in RA0 that if you're going to the corporate network in North America, that you need to use the /64 from the corporate space. So that means we can keep the corporate routing tables nice and clean. Equally, if we're egressing to an Azure property through the ISP link, we would use the prefix that's assigned in RA1. So and then therefore we can sort of cleanly divide the traffic up like that. So I think that's pretty elegant. So I think in conclusion, some final thoughts. I think dual stack is hard, and I think hard and expensive. So I think moving towards V6 only, I think is it is obviously the long-term goal. But I think even I mean, I've thought about this a bit. I think even new segments, for companies, I mean, what you could either deploy a dual stack or you could deploy V6 only. I think if you plan from the outset for new segments for V6 only with the DNS64 NAT64 solution, I think that's probably an easier and a better long-term bet. We still need to solve this sort of multiple prefix issue, and I think that's not going to go away. And I think, although I think there are a lot of companies looking into the idea of local egress, and that's not the only environment where you're likely to have multiple prefixes on the same segment. So making an intelligent, or having the client make an intelligent decision about what source to use will be important. And I think, as I say, it'll give you a lot more flexibility, and there's a potential for innovation there. I'll just finally conclude by sort of pointing there's some great IPv6 stack updates for Windows 10 Creators Edition listed at that sort of blog entry there. So I'd encourage you to go read that. So that's all I have. So I'm happy to take any questions either here or outside, or say over a beer or coffee, whatever.
Eric Klein, Google. Thank you for the presentation. Can we take this from your statements that Microsoft might implement support for provisioning domains?
This is really from an IT point of view, so I wouldn't be able to speak on behalf of the product groups.
Do you know if information about PVDs can be routed to the right people?
I could certainly have that discussion, but as I say, if this is we will be looking at these problems independently.
So this is Dave Taylor, and yes, it's already been routed to the right people.
Great, thank you, Dave.
Thanks, Dave.
Lorenzo Colletti, can you go back one slide, maybe?
This one?
I love this slide. I absolutely love this slide. This is what we should be doing. And major props to you to showing up and pointing the way here. I think this is super useful, and it really explains what we need to do, I think, to do multi-homing without scalability issues, without NAT. It's great. And I think it's it is a major driver as well for the PVD work that we're seeing happen outside MIF, but also actually happening right now. So I guess one question is, like, what can anyone do to help this? I mean, we can go off and build it maybe, but what else is, so suppose that we did have PVD just along the lines of what Tommy's draft proposes. What else is missing? I never liked 5.5. It seemed like a hack. This seems better. What else are we missing? Do you have this written up in here? Like, here's the pieces that need to happen. If you don't, then we should write it up. If not, then we just go off and build it.
Yeah, no, I think no. I mean, we've been involved in discussions with the draft, the PVD draft. So I think that's a good starting point. But I agree on the 5.5. I think it's useful, but is it?
So I'm just going to answer one of the variations of one of your questions, which is what could we do to make better progress in things? I said the request for PVDs and stuff have been routed to the right people. I think what you guys could possibly do is, if you have an enterprise network that is running into the same problem, send me email and say, I'm an enterprise network, I'm running into the same problem, because the more such emails that I have, the easier it is to argue for the higher priority, right? Yeah. And so the faster it happens, the more. So what you can do is send me email, and I will make sure it gets routed, and in that email say, I represent the following corporate network, and we run into the problem that Marcus showed on the slide. Thank you.
General enterprise networks suffering from that problem. One minor comment. First of all, you must be really, really lucky if you can use longest prefix much anyway, because you must have just one V6 prefix for this to work, right? And one question. Can you share your experience in terms of what percentage of your users had to fall back to dual stack after you connected them to V6 only? What was your experience? Did your support line was that melting because nothing worked? Or it was like some reasonable experience related to the previous discussion we just had?
Yeah, and I think that's a sort of a germane question, because I think where we have enabled V6 only is to support product groups and ourselves in IT. So I think, because, just referring to the conversation earlier on, I think technology people are sort of more inclined to sort of work with that. So, and probably a lot of the issues have been solved by themselves, rather than them being infrastructure issues. So I think, so we haven't seen any large, sort of leap in support issues.
Tim Chen, so as one of the co-authors of the node requirements update, we were going to put in there, or it's currently going to go in there, about adding a recommendation to support 5.5 in hosts. Do you now think that's a good or a bad thing to do? As Lorenzo said, it's a hack. Is it better that, I don't think we're in a position yet to put any words in that about this. It's too early. But should we put in 5.5?
Well, I think to do this, you're going to need this.
Yeah.
I think having the multiple RAs from the different link locals, I think is
so.
Yeah.
What we do have out of the MIF work on PVDs is the RA, and I'm sure Lorenzo will have the DHCP option to convey PVD information. Is that something that we should mention?
Sorry, rephrase the question.
So one of the documents that came out of the PVD work in the MIF working group before that seemed to fizzle out was an RFC that includes both an RA and DHCP method for distributing PVD information.
Right.
Is that something we should put into node requirements? Was it too early? Or
I mean, just speaking personally, I think it's easier putting it in the RAs. I think that'd be my my views. So I think obviously in some, for older operating systems, you're going to need DHCP for stateless for options and so forth. But I think but they're not going to support PVDs anyway.
May I hijack the line quickly? Multi-homing draft has a long section explaining why it not seem to be feasible to do multi-homing with DHCP. In the last revision, I added a little bit more text on this, so I don't know, maybe I'm missing something, but I just could not see how you can do that. It should be done with the arrays.
Right, okay, I don't want that. I think what we're saying is put the 5.5 text in node requirements BIS, but it's too early to put in anything about the RFC that mentions the methods for conveying PVD information.
Yes.
Responding to him.
I want to correct that. There are no such methods. There was the MIF working group had briefly considered, hypothesized such methods. And then somebody said something at IPR, and the working group was shut down. And that's all I can remember.
So Dave Taylor, I think I'm just going to be arguing for the same thing, which is the best you can do right now is 0.55. And if you actually had all the PVD stuff, then Rule 5.5 is no longer useful, right? Because it's sort of been obsoleted by the more flexible mechanism. That said, there's still possibly some value in saying something about 5.5 for the case of routers or provisioners that don't yet communicate that information, even if you had that RFC, right? Because this is something an existing host can do with existing information they're getting from the network, and it provides a better answer. And it's not as good as what it could be, but so it's Rule 5.5 becomes useless once there's no longer any networks in the world that don't provide PVD information.
I just wanted to clarify, I mean, it's not that 5.5 itself is a hack. It's relying on 5.5 to do this kind of thing is kind of a hacky solution.
Yeah. Understood, thanks.
John Linkova, I was under the impression that for the recent multi-homed host RFC says that hosts should kind of have Rule 5.5 anyway, right? So, and I agree with Lorenzo, Rule 5.5 is a nice hack, tactical solution. I mean, relying on Rule 5.5 is a tactical way to solve some of the multi-homing problem. It's nice to have currently.
Yeah, I mean, it's difficult. I mean, you can do some scenarios with 5.5, and as long as you have, RIOs in the RAs, then you can respond to that. Then you can, dictate that one RA, again, obviously one source is you can reach these prefixes, and then the others can be used as a default route. and then use that source. I guess so. That's kind of, I guess that's an implicit PVD. But I guess but it still requires 5.5 because the RAs would show up from different linked locals.
Okay, well, thank you much. So we're at the end of half an hour for this. Is there any other comments that people want to make? If not, we'll move on to the next one.
Thanks very much for your time.
I need to talk to those Apple guys.
Thank you.
Yeah, really. Okay, so where are you? Here he comes. Okay, good.
Hello. Oh, that's loud. So my name is Vaibhav Bajpayee, and I'm a postdoc at TU Munich, Germany. And today I'm going to talk about a longitudinal view of dual stack websites, failures, latency, and happy eyeball. So this is joint work with my PhD advisor, Jürgen Schönwalder from Jakobs University Bremen, Germany, and Steffi and Sam from Sam Knows, who are based in London. Okay, so if you look at the literature, academic literature, you will see that large body of work has been done on measuring V6 adoption. But there has been very little work on measuring V6 performance. And so this study actually closes the gap. And if you look at the plot at the top, you will see that we have been measuring performance, both failures and performance of dual stack websites since 2013, so for the last 4 years. And I don't know if you see, there is a gray shaded region on the top of the plot, which is showing the duration of this longitudinal study. So we have been doing this since 2013. And you can also see the correlation with the amount of V6 adoption that is seen by Google. So back when I started the study, V6 adoption was around less than 1% as seen by Google, and which has raised to around 20% as of today. This seems like a perfect time to do the study, to be able to see how V6 is evolving with time. And so how do we do this? So we utilize these Sam Knows probes. Sam Knows, if you know, it's a company based in London, which is giving out these TP-Link routers to people for doing broadband measurements. And so we utilize this platform. So we have these probes and we give out to people who get native V4 and V6 connectivity at home. And so so the map is actually showing you the deployment of these probes. We have around 100 Sam Knows probes deployed all over the globe. And it's covering around 66 different origin ASs. And there are some people who are actually sitting in the room who are hosting this probe for me. So thanks a bunch for hosting this probe for multiple years. And you might also see that most of these probes are deployed in residential settings. So the measurement is actually largely being done from home networks. So why home networks? So that takes me to the top of the plot. So if you look at the top of the plot on the left, you will see the V6 adoption trend over weekends versus weekdays. And what you see is, and so this is weekends minus weekdays. And so if you see anything on the positive scale on the V6 adoption, you will see that there is more V6 seen by Google over weekends than over weekdays. And this is largely because there is more V6 deployed in home networks than in enterprise networks. And what you see over the timeline is that this drift is actually starting to increase over the years. So starting 2013, we started to see this drift happening. And this drift is constantly increasing, which is also worrisome because enterprise network seems to be falling behind. And so that's another way of looking at this. And if you look at the bottom of the top plot, you will also see that the adoption of Teredo and 624 relays has also gone down over weekends. So this seems like people used to use these relays for getting onto V6 before 2013, and given that V6 deployment started getting on track at home, people started using native V6 at home. So that's the whole point of the top plot. If you look at the bottom plot, that's actually a side story. So we have, as I mentioned, around 100 Sam Knows probes. And we noticed that in one of the probes, which has native dual stack connectivity, that probe was not able to receive V6 services to any of the Google properties, but they were able to reach other services. And so that took us to the side story where we saw that actually Google maintains a blacklist of some prefixes, and these are prefixes of public resolvers. So if clients are behind these public resolvers, they will not receive V6 connectivity from Google. And so the pie chart is actually showing you the distribution of those prefixes as seen recently in 2017, and it shows where these public resolvers are located. So they're largely located in Japan, Peru, Malaysia, and Brazil. And so the probe that I was talking about is actually deployed in Japan and doesn't receive V6 connectivity due to this blacklist. But that's a side story, just thought to mention this. If you look at the time series on your right, this will show you the adoption of, so how many websites in Alexa 1 million have quad A entries in DNS, and how this has evolved over the years. So this data set is actually coming from Dan Wing, and I'm just plotting that data set. And so what you see on the top of the timeline is that there's a bent in the curve, both that happened during the World V6 Day and World V6 Launch Day, which is kind of obvious. But look at the larger dent that happened recently in fall 2016, and that's the shaded region. And that's when Cloudflare decided to remove the opt-in service and enabled quad A entries for all websites within their CDN infrastructure. And so that dent is actually steeper than the dent that was created on the V6 launch day and V6 day. So that goes to show that a CDN can play a leading role in not only pushing any new technology, that also happens with Google Quick, but also shifting significant traffic overnight over V6. So that's my takeaway from this plot. Okay. So what have we done with the SAMNOS probe? So there are 4 contributions that we provide. These are 4 large contributions. And so we look at complete failures of these dual stack websites, partial failures of these dual stack websites, and we'll talk more about this. What do I mean by complete and partial failure? So complete failure is when you try to reach a website, you don't get anything. Partial failure is when you get some portion of the website. And so this is relevant because these failures tend to silently exist because clients do not notice them because they tend to fall back to V4. And this also makes me wonder whether websites which have partial failure can be deemed IPv6 ready. Can they? And the last point is the quantification of these failures is actually very helpful for upcoming V6 only networks. And that's also one of the pointers in the new charter for the agenda. And that's why I want to show some of these results. Apart from failures, we also look at performance. But in performance, we largely look at latency aspects of how this latency compares over 6 and 4 towards these websites, and how all of this combines together towards this standard RFC 6555. And can we do something about it? Can we make an update to it, or does it actually need an update? And so overall, this is the first study which has been looking into dual stack websites for such a longitudinal time, for 4 years, both failure and performance aspects. Okay, so let's look at some results. So the first thing is complete failures. So if you look at the plot on the top left, that's actually showing you the same Alexa timeline for 1 million Alexa 1 million websites which fail to make a HTTP connection. So these websites have 40 entries in DNS, but when you make a HTTP connection, they tend to fail. And so you don't get anything when you make a connection over V6. And what you see is that the failures were around 40% back in 2009. And these failures tend to have reduced to 3% today. 3%, which is also a large number. And so we started wondering, what are these 3% websites? So now look at the plot at the bottom. And what you will see is the distribution of these 3% websites that tend to fail today, and where do they rank within the Alexa ranking, right? So the plot at the bottom is actually showing you that 88% of these failing websites have ranks which are above 100K. And So it's showing that most of the websites which are less popular in the Alexa ranking are failing over HTTP over V6. There are only 1% websites which rank below 10K, and there are only 6 websites below 300. So largely popular websites which are hosted by large CDN providers, they work fairly well. And but there is a long tail that still exhibits a complete failure. We don't see anything. So what are these 6 websites which are the most popular and ranked below 300? So if you look at, so these are the 6 websites, and the plot is showing you the time series of, so blue is V4 and red is V6. And I don't know if you see, but in each of the time series, you will see a vertical marker showing when these websites stopped providing Cord A entries in DNS. So for instance, Bing was part of the World V6 launch day, and at some point in late 2013, it stopped providing Cord A entries in DNS. So the bottom line here is metrics, any metrics that are being used for V6 adoption should account for changes in V6 readiness. So if anything is giving you Cord A entry today, it's not safe to assume it might give you Cord A entry tomorrow as well. So constant monitoring is also essential. Okay. Then we started looking into, given that we found about this Bing.com, I wanted to look into, okay, what all websites participated on the World IPv6 launch day, and there were around 3,000 websites according to Internet Society website, and the promise was to permanently enable production-ready V6 on the internet for the participating websites. So we looked at what is the state of these participating websites today, and what we saw is that 8% of these websites do not provide either A or Cord A entries in DNS. So most likely they just don't exist anymore. And so if you take out that sample, and if you only look at launch websites which have A and Cord A entries, you will see that 1% of those websites tend to time out over TCP, both over V4 and V6. If you take that out as well, then you will see that 8% of the rest of the websites which have both A and Cord A entries work over V4, but they tend to TCP timeout over V6. And so if you look at the plot, that shows you the distribution of the ranking of those World IPv6 launch day participating websites that fail over 6, but not over 4. And again, what you see is it's heavily tailed. So only 3% of the failing websites have rank 10 less than 10K, while most of them, 3/4 of them have ranked more than 100K. So again, it's in the long tail where the websites are failing. Okay, so this was largely about complete failures where you don't get anything. Now we talk about partial failures, where you get some content over V6 of a website, but not everything. So we looked at Alexa top 100 websites that give out Cord A entries in DNS, and we saw that 27% of these websites have some partial failure when fetching content over V6. And so what are these 27 websites? So now look at the table. So these are the 27 websites that have some partial failure over V6. They do not fail over V4, but only over V6. And so the column will show you what percentage of failure you see over 6. And I highlighted some of the websites in red, which I consider popular, but this is just from my own vantage point, so it might be different story for different people. And if you look at the top of the horizontal line, you will see that 9% of the websites have more than 50% failure over V6. So half of the content you don't get if you're sitting in a V6 only network with no translation. Yeah. 6% of the websites completely fail, which we already talked about. And if you look at the last column, you will see that the ticks are on websites which participated on the World IPv6 launch day, and again promised to turn on V6 for their services. So the takeaway here from this slide is that if any metrics that is limiting observation to the root web page, like index.html, will always give an overestimation of V6 adoption numbers, because you're actually not looking at the content of the website. And at this point, I'm again wondering whether websites which have partial failure over V6, can they be deemed IPv6 ready? Can they? And so in order to support this effort, ISOC is actually now supporting development of tools where you can go to a website and enter a URL and tells you what fraction of failure do you see when fetching content over V6? Okay. We also did some root cause analysis of why do you see partial failure happening over for these 27% websites. And this is largely happening because some of the content is just not having coordinate entries in DNS for the website. So there is failure to DNS resolution for coordinate entries, and this is largely happening for images, JavaScript, JSON, and CSS. So think about it. If there is a website that fails to load the CSS over V6 only without translation, how would it look on a V6 only network without translation? And so again, these failures tend to silently exist because clients do not notice them because of V4 fallback. And again, so identification of these operational network issues are relevant for upcoming V6 only network, because at some point in time you might want to remove that NAT64 translation. Okay. We did further root cause analysis, trying to see where is this failure actually coming from. So we saw that the failure is actually coming from both same origin and cross origin sources. So what do I mean by same origin? So let's take an example in this plot. Let's take the case of yahoo.com. So what you see is that 28% of the content for yahoo.com is failing over V6. So I want to know how much of this 28% content is actually coming from star.yahoo.com. So the same origin source. So now look at the table on your right. You will see that 83% of the stuff that is failing over V6 is coming from the same origin source. So star.yahoo.com. So Yahoo can do something about this, right? And if you look at the top of the horizontal line, you will see that 12% of websites have more than half of their content coming from the same origin source that fails over V6. So you control that website, so you can do something about this. And so John also pointed me to this pointer that, so it's largely also about the CDN infrastructure, which is hosting that website. So the CDN infrastructure also has to turn on V6 for all the web page elements, whether they are same origin or cross origin. Okay, then we also looked at cross origin sources. So this is just flipping the story and trying to see what cross origin sources actually fail over V6 for a website. And these are largely third-party advertisements, analytics websites, user-centric websites, static content, and this is all the stuff that is actually failing over V6. So it may or may not be good news. And so the takeaway here is also that enabling V6 on some of the cross-origin sources like Creative Commons, because it's largely used by many websites, and this is shared by many websites together, which will actually help reduce partial failures for multiple websites. Okay, so up until now, we have been largely talking about failures, so complete failures and partial failures. So for websites which actually do work in practice, both over 4 and 6, we also started looking at latency aspects, and this is something that we have been doing since 2013. So it's a 4-year long data set. By latency, I mean TCP connect times. So it's largely measuring the amount of time it takes for the connect system call to complete. And this is not taking into account DNS resolution time. Okay, and so if you look at the plot, this is showing you latency 4 minus 6. So if you see anything on the positive scale, that means that V6 is faster for those websites. And what you generally see is that back in 2013, 2014, situation was not that good. So for instance, Facebook.com, which is the green line on the top plot, it was like 100 milliseconds slower over 6 than over 4. But if you see now, things seem to have converged to 0, which means that latency is actually congruent over both 4 and 6. So you don't literally see any difference, at least for these popular websites. So in a separate paper, we also tried to identify why we had inflated latency over 6 than over 4 back in 2013 and 14. And this was largely happening because when you're reaching content, you were hitting a content cache in the ISP's network, which was not dual stacked. So you were hitting the cache over 4, but you had to go further away to the CDN to fetch that content over 6, which was increasing latency. Okay, so at this point, we were also wondering how is the state actually looking today? And so this is the state of latency for Alexa top 10,000 websites that do work. And so this is again 4 minus 6. So anything on the positive scale is good for 6. So you see that actually 40% of the websites are faster over 6, while like 94% of them are at most 1 millisecond slower. So this is fairly good news. And so Alexa Top 10K, I would assume that most of this stuff is hosted on large CDN providers like Akamai and Cloudflare. So websites hosted by large CDN players, they tend to show no difference over 4 and 6. There's again a long tail, so 1% are at least 100 milliseconds slower, but I would assume this will change in time. So I would assume that this plot is actually relevant for content providers because they want to know how their service delivery actually looks over 6 and how it compares over 4 as seen by clients which are sitting at home. Okay, so how all of this comes into the picture for happy eyeballs. So given that we have this 4-year long data set, we also looked at the entire distribution. So blue is, so if you look at the top plot, you will see that this is raw TCP connect times. And this is the entire sample. And so blue is 4 and red is 6. And what you see is that only 1% of the samples were ever above the happy eyeballs RFC 6555 timer value of 300 milliseconds. So it's only in 1% of the cases where happy eyeballs actually came into the picture when deciding whether to choose 4 or 6. And the repercussions of this you actually see in the bottom plot, where you see that almost for Alexa 10K websites, 99% of all those websites were preferring V6 98% of the time, and which is good news. And so this is largely leaving 2% chance for V4 to succeed. But if you look at the samples where happy eyeballs is actually preferring V6, you will see that in 90% of the cases it was actually preferring a connection over 6 which was slower than V4. But if you also look at the scale of the x-axis, you will see that the scale is not that high. So in like 7% of the cases, the difference between 6 and 4 was like 10 milliseconds. And so at this point, we started wondering, can we do something about the timer value? So what happens if you reduce the timer value? And so if you look at the bottom plot, you will see that at this point, what we were doing was we were controlling 2 parameters. So the idea of happy eyeballs is not to move traffic away from 6 to 4, and that's why we didn't want to compromise on the preference that you get for Alexa Top 10K websites. So 99% of the Alexa Top 10K websites should still get preference 98% of the time. So you control those parameters and then try to lower down the timer value and see up until when this preference holds. And this is what the plot at the bottom is showing you. And this is showing that up until 138 milliseconds, it tends to hold, and after which it tends to go down. So I gave it some buffer space, and it seems to show that even if you use 150 milliseconds, it will give you the same preference levels for all these top 10K websites. So it will not move traffic away from 6 to 4, and it's going to have the same impact as 300 milliseconds. And so in the paper, we also showed the time series of what would have happened if we would have used RFC 150 milliseconds from the very beginning when the RFC was defined, and it would have made no difference whatsoever. And so this goes to show that measurements should inform protocol engineering. And we hope that this data and the results can be used as input when updating RFC 6555 within the IETF, which is happening now. Okay, so none of this work would.
I want to back up one slide.
Okay.
Hi, David Skenazy, one of the authors of RFC 6555-BIS. This is cool, and please collaborate with us on this. We'd love to have your input.
Perfect. Thank you.
So, go ahead.
Okay, so none of the stuff that I have shown you would have been possible without the help of all these amazing people. And this also includes everybody who has been hosting a probe for me. And hosting a probe for 4 years is it's a challenging task. And you have to trust a stranger to host a probe at your home and trust that they will not do passive measurements. And so thank you to everybody who has helped in the study. So the failures aspects that I showed has been published in 3. So the slides might have been online, so you can also look at the paper. The latency aspects were published in 4, and the happy eyeballs aspects were published in 5. And so that's about it from my end. And at this point, I'm happy to take questions.
Jordi Palet, thanks for this work. I have three very quick questions. The first one is some nodes is not using anymore TP-Link. They are using their own box. Are you still able to use your code in that box, or there is some difficulty there?
So that's
it's
correct.
Still OpenWRT, so.
Yes, that's correct. So SamNode has its own hardware as well. And so the last 20 probes out of the 100 that we shipped out are the new probes. And it's largely running OpenWRT, and the tests are written in C, so they don't make any difference. It's largely the interface is 1 gig.
Yeah.
On the new hardware.
5 1 gig interfaces.
5 1 gig interface, and that's the large difference. So in terms of measurements, it doesn't make any impact whatsoever.
The other question is, in one of the slides you mentioned there is only 1% of failures over 100 milliseconds.
Yeah.
Right? Have you considered if that's probes that are using tunnel brokers, which is my guess?
So again, so I did not want to have any of the results biased by some or other probes. And so this is largely showing the median. So this is general behavior as seen by probes. And so this has no bias. So if one guy decided to start using a tunnel broker, it will not show up in the results because it will go in the outlier.
I'm not sure I got you. You mean that you are not differentiating if somebody is using a tunnel broker because you're assuming that everybody is dual stacked natively?
So there are 100 probes, right? And all the 100 probes are sending results. So you get a sample, and then you take a median of that. And if you take the median, the tunnel broker will go on either on the left side or the right side of the distribution. So this is actually only showing the median, which is the general case. And given that most of the probes are native, the general case is native.
Okay. I think it will be interesting anyway if you can make one more slide or something explaining from the n number of probes that we have, there are 2 or 3 that are using tunnel broker to show, because it can change the average a little bit, not too much, but a little bit. And the last question is, you are not considering anything else than happy able. So for example, path MTU break is not being considered on this measurement, right?
Yeah. Yeah.
Okay.
Yeah, that would be good future work to look into. Yes. So that's a real problem. We also see it, and PMTU issues cause black holing, and we would like to see if we can do some measurements on that.
Let's talk together later on.
Perfect.
Okay. Stephen Strauss, Ripe NCC. I no longer have my Yahoo hat, but you called out Yahoo, so I think I can talk about what you were measuring with your partial failures. What you've kind of measured is our approach to lighting up content. We lit up things that people would actually maybe want to see first, like actually real content. And for secondary domains that pages requested after that, we didn't necessarily chase those first. So we got to them eventually, but we lit up actual content first. And things like, say, advertisements, we didn't get to so quickly. So if you wanted to disable certain types, I'm no longer an employee. If you wanted to enable certain types of tracking or advertising, just turn off your IPv4.
Lee Howard, I actually did a comparison kind of like that at a Nanog a couple of years ago, where yes, I showed that, if you go to a lot of these websites and your CSS doesn't load and the ads don't show up, actually the experience is kind of good, right? You don't get the ads.
Yeah.
You had suggested a number of 150 milliseconds as a proposed latency number for happy eyeballs. I know David said, please come and help us co-author. That sounds like a point-in-time recommendation.
Yeah.
And that's something that you've actually talked about earlier. So do you think that number is going to stay at 150 milliseconds for the lifetime of RFC 6555-BIS? Or do we need a mechanism that's even more responsive somehow?
Yeah, that's a very good question. So I hope it does stay constant. And so Jeff actually asked this question at one point when I was presenting before. And so what is actually the point of reducing the happy eyeballs timer value? The point is it helps us to know when we can turn off V4. So if we can turn down the happy eyeballs timer to 0, and still the traffic does not move from 6 to 4, then we know we can actually turn off 4. And so what we have seen is that in 4 years, you can actually halve the timer value. And I don't think this is linearly decreasing. And so in 2 years, we might still want to look into a new timer value, but hopefully you might be able to halve it again.
David Skenazy, Apple. We're actually going in the exact opposite direction. So first point, I agree that having a fixed value is not the best thing. So what we have in our OS is we use the measured RTT to inform what the timeout should be. So it depends on if we've been doing networking for a while, we have a much more granular value. So that RC6555-BIS recommends doing that as well. But actually what we're doing is not reducing this timeout, we're increasing it, because what you're doing when you're reducing it is you're increasing your chance of going over V4, which is not what you want. The only purpose of happy eyeballs is to catch these failure modes that you describe when V6 doesn't work. And those are getting, as your numbers show, rarer and rarer. So when happy eyeballs fires and you're close, it's a false positive. So increasing the timer little by little makes us use V6 more, and it only becomes handy when it's really just a critical failure, which we still want to not completely fall over and wait 30 seconds, but we can afford to wait longer and longer.
Okay, so there are 2 points made in that comment. So the first point I actually agree with. So having a dynamic timer value might be very useful, because then we don't have to update the RFC every now and then. Using the latency or RTT history might be useful as well. So I completely agree with that. So if we can do this, then we don't need a fixed timeout, and then we are done. And for the second part, I'm just wondering, so happy eyeballs wasn't it designed to actually quickly fall back when you actually see failures, right? And if you keep on increasing the timer, then you actually don't need happy eyeballs, because you're back to the same story where you see long timeouts, which we were actually seeing before happy eyeballs. So the idea is to not move traffic away from 6 to 4, and given that 6724 gives us this preference to choose 6, and in cases where you see failures, you should be able to quickly fall back. But how quickly you want to fall back is something that we have to decide. So if we keep this too long, then we are back to the same story where we are not falling back quickly.
Depends what you mean by too long. What we were seeing before was 30 to 60 seconds, which by that point the user has closed their browser and thrown their phone out the window.
Yeah.
But increasing it to one thing we can increase is the lower bound on the RTT. At the end of the day, the user may notice 500 milliseconds, but it might be a way to kind of put pressure on the operators whose websites are broken, that you still want there to be a little pain so people actually fix their brokenness.
Mm-hmm. I would suggest let's discuss this when we have your draft open.
Yeah, Lorenzo Colletti, as someone who was involved with the first Happy Eyeballs implementation that got shipped, which was done in Chrome, the 300 millisecond timer was chosen because we already have a 250 millisecond timer, and we wouldn't want to get confused by looking at the graphs. That is the engineering that happened. Now, you might think that was dumb, but in reality, the thought was it was not intended as a performance optimization. It was intended as a fail-safe, and it was never intended to be almost as fast as you'd notice. It was kind of intended to be, well, something is wrong, and we're not going to try and bend over backwards to make it right. So there are other implementations that have historically been more or less, ruthless. I mean, the Microsoft implementation says this network isn't working, I'm just going to give up, never use V6. The Apple one was very, very it's very, very intention to maintain performance at all times. One point that I wanted to make is that if you set the time to 0, you use V4 50% of the time exactly. So setting the timer to 0 is never a goal, right?
Yeah.
So, to be honest, I don't think that 300 milliseconds are a problem here. I mean, I think the fact that the major implementation of Happy Eyeballs, which was the most ruthless, which was Apple's, is slowly moving towards giving V6 preference should kind of be, I think that's the way we're going. So
So I just want to point out to the fact that you were saying at 50% you will see using V4, and that's what actually the plot shows you, because the 50th percentile is actually hitting in the middle. So if you lower the timer value to 0, half of the stuff will go over 4.
Yeah, because you're measuring noise.
Yep.
And that's clearly not the right outcome, right?
Yeah.
Because you've got two things that are perfect, and if you also want to prefer V6 over V4, then you can't do it that way.
Yeah.
So, okay, thank you. Lee?
Hi, my name's Lee Howard. I'm here without a hat on. I had been asked to do a presentation. Thanks, Warren. I appreciate the offer of the hat. But I'm not taking your hat. No, I'm not taking the area director hat. So a couple months ago, I was asked if I would contribute some information, some slides about what is the state of IPv6 only on the internet, and this is for a series of some of our working group chairs. And so I did that, and a couple of people said, that's really interesting work, would you share that more broadly? I've written a blog post about it, but here are some of the slides. The first couple of slides are things that most of us have seen already, but not everybody has the entire history that some of us do. So if you've never seen this, I've got all the URLs at the bottom. Google is doing some active measurements of IPv6. This is connections that they see from people hitting Google sites over IPv6. And so we're up to just about 20% worldwide. That's pretty fantastic. And you can see it's up to the right. The important thing on this one is this, and I think the previous presentation described there's this weekly change. So weekends are higher, weekdays are lower, because enterprises are lagging on V6 deployment. So that distinction is pretty significant. So it's probably where we got to pay some attention. On the same site, different tab, you can see that there are lots of countries that have various levels of V6 deployed. They color things red when there's a higher latency over V6. ISOC has been, since World IPv6 launch, has been collecting statistics from several content providers and sort of blending them together, and they provide these numbers. You can click on any of those sites and see that provided that ISP's performance or their V6 deployment over time. Pretty good numbers there. Obviously, these are the top 10. They're sorted by number of eyeballs, not by percent of deployment. I guess by number of eyeballs over V6. Eric Vinke is doing some fantastic pushing agglomeration, I suppose, of some of this data. On the left side is top countries. This is measuring the Alexa top 50 for each country. What percent of the top 50 have IPv6? He's got it weighted, and the green column is the raw number of the top 50 that support V6. The weighted number, I believe, is weighted by number of DNS hits. So that is a sort of a way to say how important are the V6 enabled sites. So a higher percentage there means those are the more important sites. There might be a sharp drop off. The countries here, to me, it's very interesting. There's some very small countries here. In some cases, are surprising. Wow, they've got, I wouldn't have thought that Tonga would be a great leader in IPv6 necessarily. Not that Tonga is not a great country. What we're seeing is that the top 50 sites tend to be hosted by companies like Google in those countries. And therefore, since Google has a lot of their properties IPv6 enabled, Tonga has a lot of their top websites IPv6 enabled. The right column is ISPs. So this is, again, the eyeball measurement. This is taken from, I think this column is specifically taken from Google's data. And so you can see, hey, congratulations. It turns out, what a surprise, that Belgium, where Eric lives, has the most eyeballs enabled over IPv6. Who would have thought that? But I'm, fairly satisfied with the United States being second in something. He also, on that site, has a place where you can do extrapolations from this data over time. And you can extrapolate based on websites. You can use Google's data. You can use Akamai's data. You can use APNIC's data. Here I've taken, and actually Lorenzo is the one who convinced me that an S-curve, a logistic curve, is the way to do this, because adoption curves tend to be these kinds of S-curves. Now, of course, any kind of prediction, it depends on what kind of assumptions you make. But still, it's fun to play with this particular tool. Here I've taken worldwide measurements as seen by Google, and said, based on the entire history of data that we have, Show me 3,000 days into the future, where will we be for IPv6 deployment? And according to current extrapolation on this, we hit 50% worldwide users with IPv6 in September 2019. That's only 2 years away. 50% of the users worldwide would have IPv6 in 2 years. That's still feeling pretty good. I think we can feel pretty satisfied with that. Obviously, these numbers change. Go plug in your country. You can do this by country. Plug in your country, and you will find where your country goes over the future. I'm very, again, satisfied with the curve on the US. APNIC has data. This is just one of the many tables that they present. This is percent by various regions. APNIC, I'm not going to get into the methodology, but they're doing ads on Google properties so that they can get users actual, Google's using their browsers to measure. But one of the things they do, so this is, I chose the US because I'm parochial, what can I say? So this is APNIC's data. This is what they've measured in the US from ISPs, but I've sorted this by the percentage IPv6 capable. Usually I sort by the number of samples because that gives me a sort of a rough idea of how important sites are, how the most important ISPs or networks are doing in the US. Here I've sorted by IPv6 capability because I wanted, yes, George?
You morally, George Michelson APNIC, you morally want to erase with your Men in Black eraser the top entry there because that's an artifact of a glitch in advertising exposure and Facebook's decision to put their own IPs behind the ads that were being served. So can we all just pretend we've had the Men in Black pen pointed at us and Facebook and not 1.5 million samples at the top?
I'm satisfied with that moral correction. So the top network then, in terms of percent availability, is Midwest Internet. This is in the US, which at 99.31% of their users being IPv6 capable, says to me they are practically, they should be practically an IPv6 only network, except, yes?
No, I'll let you finish. It's just, I wanted to give you some pat on the back time, but it can wait.
Except that almost none of those are actually preferring IPv6. So Midwest is a very small network.
So that becomes a pat on the backside?
So that, right. So I mean that's amazing. I have not actually contacted folks at Midwest Internet to ask them what their story is, because I'd be fascinated to know how that's going. Yes, John, that's your turn.
So you gave me a throwaway comment in the corridor last night.
Yep.
I believe that the 10% uptick that you have on your graphs is because of Charter, Cox doing some stuff. I just looked at 3 of their ASs. You are on the money, Lee.
Yeah.
You called it.
I called it.
Yeah.
So what he's asking about is, yesterday I was looking at their charts, which I haven't included here, and I saw that the US has jumped by somewhere between 5 and 10% number of users deployed in the last 2 or 3 months. 5 to 10% deployment in 3 months is incredible, especially in a country the size of the US. And it's down to 2 companies, Charter and Cox, second and third largest cable companies in the US. And so I was actually on Reddit yesterday. Somebody was complaining that they wanted to shame Charter for not deploying IPv6. And I said, look, there's hope. Here's data. The reason I keep showing this chart, though, and this is, by the way, I've actually done some cherry picking here. This is not the top 25 or whatever list of networks. This is some that looked interesting and representative to me of what's in the top sort of 60% and above IPv6 capable. And the reason I did this is I wanted to sort of characterize. So first of all, I wanted to say, look, a network that has 98, 99% of their users V6 enabled is a network that's essentially ready for IPv6 only. They can turn off IPv4. The only reason they haven't is because the rest of the internet isn't ready. In fact, they might be ready to go to some kind of V6 only plus translation. Some of these may be doing that already, we don't know. But I also wanted to point out some of the sort of typical demographics of these networks. So we have some ISPs like Midwest. 9X, I'm assuming, is part of Verizon. I don't know what is 9X anymore. We've got, and then we have, Google. Actually, I think Google's on here a couple of times. Verizon's on here a couple of times. We have several universities, and I've only included a few of them because a lot of universities have done major deployment of IPv6. And what I'm guessing is that they're able, once they've enabled their network, because they have a turnover every 4 years in the large proportion of their population, they get new devices. You don't tend to find a bunch of ancient devices at universities. Chris is going to disagree with me? That's not the 9X I think it is. That's 9X in Germany. I wonder how I'm showing 9x in Germany based in US. You know what? I'll bet that's George's AS location algorithm that's showing that up. Yes, okay. So we also
saying it's all George's fault.
It's all George's fault. No, I'm not going to say that it's all George's. Well, actually, I'm going to say it's Croft in the data, because I think that he's using data that's in the who is for that AS to determine that it's a US AS. Yeah, so that's what I really wanted to show here. So, but these are networks that are essentially V6. I mean, they're essentially done, right? And like I said, this is not just 25 in the US. There's 50 or 75 or something that are in this same range that I just cut in order to make it fit on a slide. So actually, Fred pointed this data out to me. Hurricane Electric does lots of measurements. They're fantastic. They put them all on the web. They hide them pretty well, though. So this one is a list of ASNs and what kind of prefixes they're announcing, which address family. Guess what? 359 ASNs are announcing IPv6 only, no IPv4. That's an astounding number. I was shocked when I saw that number. There are 359 networks that are IPv6 only on the internet. Now, I haven't actually been able to figure out how to programmatically compare those networks to see if they have an IPv4 only ASN that parallels the network. At least many of them do, but I haven't been able to do that rigorously. Yes?
I've deployed multiple networks where we announce a v6 space because we can get it, and then we have a /28 from our upstream for stuff, including NAT64, and we obviously don't announce it because it's not ours. So I wouldn't say those networks are v6 only, really. They just they just don't know how to announce a v4. They don't have any v4 to announce, and they can't. So
hey, if you're a v6
yeah, they
only,
kind of are.
They're kind of well. So
yeah,
I want to come back to at the end of this. What's the definition of v6 only? Because that's sort of been going on the list also. But I will say that many of these, like I've done a few spot checks. I haven't been able to do it systematically, but the spot checks, they tend to be research or academic networks, many of them, not all the ones that I've looked at. And so it wouldn't surprise me too much to know that a research network is deploying an IPv6 version of their network, either as their next generation network or as just as a parallel way to manage their IPv4 and IPv6 address family networks. Still, 0.5% of ASNs announcing IPv6 only, I don't think is completely nothing, especially since I first did this, like I said, a couple of months ago, and as I was updating this earlier this week, gosh, it's only Tuesday, I found that number has actually grown measurably, from 0.55% of ASNs being v6 only to 0.61% of ASNs being v6 only. That's nothing there. That might be that most of the new ASNs are coming up v6 only, but I haven't been able to confirm that either. Just cycles. We've seen this slide before. I don't know why I'm pointing at David, because it was Tommy who presented it. But this is this is in MapRG, the rise of v6 only hosts. Look, there are indeed v6 only hosts. This was at IETF. I attribute this to initiatives like we heard Marcus earlier. We've heard folks at Cisco talking about their v6 only building and their project. We've heard from TerraStream being a v6 sort of testbed network. They're doing interesting things there. T-Mobile, of course, that's no surprise. LinkedIn, Facebook, everybody has talked about this. My company is doing translation as a service. I believe that there's going to be v6 only, and I should be doing, and there's room here for work to be done. So what are the reasons? Well, we've just seen more measurements on latency. We've got tons and tons of data now, of reports from the field saying that v6 is at least often faster than v4 in terms of latency. It is measurably faster. It isn't always faster. I don't want to overstate the case, but there's definitely measurable difference, and go search the links or go see go see those sites, and you'll find more data. Marcus was talking about some of his reasons for v6. Certainly that's there. I gotta say, if you haven't, probably many people in here have done this, but if you've tried subnetting in v4 and doing the math between .192 to .223 and what's the math, what are the hosts, and trying to add 32 bits to something in the oh man, math is hard. You do this in v6, and it turns out it's really easy once you get the hang of it, which is 10 minutes of practice. Segment routing is a cool new application. You can do interesting things like number. You've got so many addresses. You can use addresses as process IDs. You can use addresses as service bits. So there are clever things that you can do once you enable that. I'm sure actually Brzezowski left, but he's got lots of his own reasons that he's talked about in public too. So here's my summary. Enterprises lag. That's not a surprise, and we've talked about, actually even today we talked about some of the reasons. Dual stack's only the halfway point. I think that we can characterize and say that IPv6 only is now where dual stack was 6 years ago, which is, again, let's do an extrapolation and see where we'll be in 5-6 years. Now, the definition of IPv6 only, this is not necessarily a conversation that we have to have. I will look to my co-chairs to, actually not my co-chairs because I'm not a chair right now. I will look to the chairs to decide whether we want to have a conversation on this right now. My proposed definition is if the host has no IPv4 address provisioned on it, it is an IPv6 only host. And therefore, there might be help for the host, but the host is v6 only. Okay, Jen.
And Jen Linkova, first of all, one minor comment. When you try to attribute IS number to country, it's always a bit tricky because, for example, you see the whole Google corporate network as a US.
Yeah, right.
Two IS numbers and.
Wait, Google has things that are not in the US? That's amazing. Hey, and Jen's being nice to you, George.
Oh, sorry. Okay, and second point, I'm afraid it's a kind of overstatement to say if 90+% of your eyeballs are seen over V6, we are ready for V6 only. Because there are things which still might depend on V4 inside, right? But if it's true, it would be really interesting what we are seeing for this IETF network. Are we ready?
That would be interesting. Maybe I should qualify it to say that if 99.8% are then you're ready for V6 only internet. But fair enough, yeah.
Lorenzo Colletti, a quibble on V6 only. When you put Android on V6 only network with an AT64, it actually does manufacture a synthetic IPv4 address. So I would like that to be considered V6 only. So you say if the network doesn't provide a V4 address to the host. But
I have a feeling Jordy's going to say something similar to that, actually.
A couple of things. Could we go back several slides to the enterprise slide to the Google beta slide?
Wait. All the way back to the difference between day and
that one.
This
yes. So what percentage variation is that, and has it been changing over time? Has it been going up or down? I don't know the answer, but it would be a useful answer because maybe there is deployment in the enterprise. Just because that that variation is increasing doesn't mean it's increasing in a percentage.
Because users do go home at night, right? So there's I don't know how to extract that information out of this. I would love to, and actually maybe some other people in the room have good ideas for how to measure that.
Measuring the delta and charting it over time as a percentage of the total might help. Right?
That'd be a first approximation, yeah.
And then if you go forward a few slides to this one, that one, yeah. So
way overstating it.
Unfortunately, I have been doing those numbers internally for a while, and a while ago they said August of 2018.
Yep.
So my S-curve isn't actually correct.
I do this too off the APNIC numbers, and I go 50% at 2021. So it's a competition, and the one who wins buys the champagne.
Hey, George, actually, so you guys, Labs APNIC, did we're doing have a blog. Actually, maybe it's not APNIC. Maybe it's some guy we know who works for APNIC had a blog where he was showing the runout on IPv4. That might be a useful projection, an ongoing daily site.
Yeah, if only that guy was tractable and could be made to do things.
Yeah, that'd be great. He's not even in the room, is he? Okay.
So I do wonder if we need to chop off the beginning of the graph or give it fake dead at the beginning.
I've thought of that too. Yeah, it does change. It's also really interesting to see. We know we get annual spikes of utilization right around the holidays, the winter holidays, because people aren't at work and therefore they're at home and they do a lot of surfing. And then we get a little dip in January, February because nobody's deploying new stuff in January, February. They're catching up with their holiday moratoriums. So this year we've had, we've seen an even better spike than last year in the middle of the year.
So an interesting data point, or interesting to me, I was looking at the IPv4 market group. Now, if V4 addresses are real estate, then they're a real estate agent. And they're trying to sell their product. And their estimate was that the price of an IPv4 address would start to fall in about 2019 because there would be enough IPv6 saturation that the interest in V4 would fall off.
There's an issue, the market dynamics, I can get into that for a couple of hours, but probably won't right now.
Jordi Palet, my prediction on this, and I will explain why in a minute, is that by 2020 will be about 70%, not 50%. Okay?
Well, 2020 is all right.
Why I believe that? Because what typically happens is when a network starts deploying IPv6, because the major service providers, content providers, delivery networks, things like that are already IPv6 enabled, the traffic jam is not like this, it's like going that way. I think that's going to happen, and as more content providers provide IPv6 service or enable IPv6 service in the networks, that trend will increase quickly. But anyway, that's just a prediction, right?
I'm not sure that I agree with that because of the law of large numbers. That many of the largest networks, eyeball networks worldwide, have deployed IPv6 and are not going to have skyrocketing numbers shooting up. So now we have to wait for lots of small ISPs to deploy IPv6. Now, they may all say 2018 is the year. Boy, we've been out of addresses at the RIRs for 2 years. Our hordes are gone, and therefore we got to go. But yes, predicting the future is hard.
Nobody have the crystal ball, right? Second point, regarding the IPv6 only ASMs, I have some customers, very few, but some, especially new ISPs or new business having their own ASN, that because they cannot get more IPv4 addressing space, they are using IPv4 addressing space from their upstream providers, okay? So that may explain a little bit this, and probably it's going to happen more and more. The other explanation, and this is very strange, I don't like it, but some people has a different ASN for IPv4 and for IPv6, sometimes because they are merchant acquisitions, okay? So they decide to do IPv6 in only one of the ASNs or whatever, okay? And my last point about IPv6 only definition, I think the point here is that we cannot talk in a generic way about what it means IPv6 only. We need to differentiate in IPv6 only in the WAN or in the core or in the customer's network, because otherwise it don't make sense. Somebody convinced me some time ago that we don't talk anymore when we have IPv6 only in the access about IPv4, but IPv4 as a service. And I think that's the way, because when we offer an NAT64 or 464XLAT or MAP or whatever, we are providing IPv4 as a service. But yes, the network maybe even the distribution network or the core network may be just IPv6, and you have IPv4 just in the LANs of the customers and in the BGP with your upstreams. That's it.
I like that. IPv6 only is an adjective. You have to have a noun, or else it doesn't make any sense.
So probably we need to have how to say, an agreement here that when we talk about IPv6 only, we define which part of the network we are talking. Otherwise, it don't make sense in a generic way.
Michael Abramson. So about the whole V6 only host and so on, I think we should differentiate between the host and the access. So like in T-Mobile, that's not a V6 only host, but it's a V6 only access. So they do provide dual stack access, just is tunneled. So it has to do with like, is the device capable of sending native IPv4 packets on its access? That should be like that part of the definition. And then you have the host. Can it talk to IPv4 space? If it can talk to IPv4 space, I don't think it's an IPv6 only host, but it's on an IPv6 only access. So I think we need to differentiate this. I don't want to talk about the addresses really that the device has, because if it has an IPv4 address on a tunnel interface, that it means that it can send tunneled IPv4 packets over an IPv6 access. It's not an IPv6 only host. I think an IPv6 only host should have 0 IPv6 address and zero capability of reaching IPv4 at all. So there was no translation, there was no nothing. But I think with the discussion, defining that, I think is good so that we are all talking about the same things. We have the terminology down right. So I think that's a good discussion to have.
Baba Vajpayee to you, Minik. So I also want to give a +1 to having a definition for V6 only, because this is creating so much confusion on the internet, and people just refer to V6 only when they mean something V6 only with translation, without translation, and then you have to contact the authors to try to understand what they mean. I don't really care whether it's a noun, adjective, or we have to differentiate it, but having it somewhere written down, which I can refer to when talking about V6 only, would be very useful.
So something I think I'm hearing is, if there's a newcomer in the room who is looking for an internet draft to write, the definition of IPv6 only would be one. And there are several of us here who would probably be happy to help you through the process and get that published. Also, if there's somebody in the room who's looking for a small research project, going through the 359 ASNs to see if they have comparable v4 ASNs, or maybe trying to figure out why they're v6 only, that would also be interesting and useful research. Victor.
Yeah, Victor Corsi. Pardon me. I would, maybe this makes it worse, but I would suggest that we connect to whatever we think the objective is. So, I mean, I'll give you an example. I'm not sure if V6 only core, is that a thing we care about anymore? Like, is there really significant technical barriers to making a core V6 only, right? I think we should connect it to, pardon me, whatever the key objective is, right? I mean, we knew for a long time getting SP networks and accesses to V6 because of the complications of home networks, et cetera. That was important. So that's an objective. So that's just my extra 2 cents there. We should connect it to an objective. I think generically it doesn't make sense, but I think wherever we're trying to help influence the specifications or fix things up, that's where we should focus our attention on. Right? Just throwing it in there.
You read my mind. 5 minutes ago, I started writing that draft. So if somebody else is willing to cooperate, let's talk during the week.
Great, thank you.
Okay, thank you much. Okay, so John, are you doing? No, it's Russ. Russ?
Well, John can do it.
Well,
I'm not partial to standing in pink boxes.
the pink box makes me crazy.
Oh, I know. I know.
Okay, stand in the pink box.
Stand in the pink box. I go to Nanog and they put me behind a podium and it drives me absolutely crazy. Okay. Russ White LinkedIn. Zaid and John are co-authors on this. Not a whole lot of changes since the last time we saw this presentation. Just some comments off the list. Remove some empty sections, things like that. The purpose of this is to take advantage of the v4, v6 transition through which changes in the net architecture can be looked at and provide a set of suggestions, requirements that providers would like to see implementers do in their routers around support. Now, I know that there are edge router drafts as well, or BISC going on. The draft since the last change, we went working group document since last IETF, and there have been a lot of changes in should must based on feedback from people off and on list. So you should look for that. Everything that's in bold in the slides is something that's changed since the last one. The stuff that's not in bold is stuff that was in the last presentation. Review the internet architecture, some stuff about robustness principle, complexity, load structure, and routers. Haven't had a lot of comments on that text. Requirements related to device management and security. Had some comments about Yang stuff. Some people don't like the Yang primarily. I'm tending to leave it in there myself because I don't care what you think. Anyway, sorry. Ethernet console support was one that came up. Zero-touch provisioning. There was a huge argument on the list. Frankly, I did not read all the messages. It was TLDR. And but the upshot is that the draft now says DHCP and Slack must both be supported by default, and Slack must be supported and enabled by default. Lots of new text in this area. I would really appreciate any feedback on this because I know this is a very contentious area and a lot of people have very strong opinions about it. So I want to make sure that this section of the draft is right. There's some protection against DDoS stuff in there. Didn't get a lot of comments on that. Requirements related to telemetry. Some people, again, said about Yang. gRPC is in there, other things like this. This section could probably use more definition if there are comments coming off the list for this. I haven't seen a lot. Topology, state and traceability, flow traceability, stuff like this, requirements related IPv6 forwarding and addressing. This section of the draft is also pretty light in my opinion right now. It could use some more help. Future consideration, segment routing, I haven't put text in there yet, but I'm assuming that we're going to want all routers to support segment routing in some type. Security considerations, I think, is a pretty good section at this point, has a good bit of stuff in it. And then there's a conclusion. We've accepted as a working group doc. Please just look and make suggestions for empty text sections and give us suggestions on anything else. We're really looking for feedback on this. We want this draft to be right, and we want to push it forward so that we can, the providers sitting in the room can tell the vendors and the folk like FR, free range routing, and other OpenStack routing stuff going on to please tell us, you know, the providers are trying to tell these people what it is we want in our routers and gear to truly support V6 in our networks, modulo the edge secure or the edge draft that's already out there. So that's pretty much it.
Okay. So comments?
I think I have one comment coming to the mic. Walk faster. No.
Hey, it's still morning. I'm Dave Plonka, one of the chairs of the Measurement Analysis for Protocols Research Group, and I wanted to invite you, well, all of you, to our meeting on Thursday morning, specifically about this. In the draft I see it says, of ICMP should rate limit the generation of ICMP messages relative to the ability of the device. And what we're going to have that morning is one of my colleagues from Akamai is going to give the results of an empirical study on what he's seeing routers are actually doing here, the different rates of depletion in their token bucket rate limiters, and the complications it's causing to switch from V4 to V6 when you want to discover the topology. So it's not something we talk about a lot about. I mean, this wasn't controversial, I think, to limit ICMP error messages, but we're running into having to do a lot of work to switch to doing V6 discovery that way. And I'm wondering specifically about the part about the ability of the device to generate that, what criterion implementers are using to determine that, or are they just picking something arbitrarily?
Right now we're just picking something arbitrarily. Well, that's what we do in the operator side. And I'm pretty sure the implementers do the same thing. So it's actually would be very good to know about that. Yes.
James Woodyard, Nest Labs.
Yes.
This document seems like it might need some more suggestions. One thing that came up, and somebody said, you should just go to the mic rather than write a mail. But anyway, the idea is,
either way,
shouldn't this say a little bit more about issues related to RFC 7934, the providing multiple addresses? I mean, I know it's got this thing that DHCP-v6 support must be there, and it's got to have configuration options for DNS, but shouldn't it say something about making sure that hosts can be assigned large numbers of addresses without having to request a single?
Yeah, that actually would be a good thing to add, and PVD would probably be a good thing to add as well, being able to support it, but I don't think we're in the position to actually add that text until we get more stuff on PVD written in other places.
Right, but 7934 is already...
Yes, that's good. Actually, send me an email, and I'll put it on my list. There are other comments on my to-do list that I haven't filled out yet.
All right, thanks.
Thanks. Now I'm going to get yelled at about PVDs.
So Lorenzo Clee, on the DHCP-v6 requirement, I love that text because you can meet that requirement by building a DHCP-v6 client in your router and no server. That's probably not the people who were pressuring you into writing that one.
Yeah, probably.
But seriously, the actual Ted Lemon said this about 20 times. For 8106, if you're a router, it's clear what it means. You have to be able to announce it. For DHCP-v6, it's not clear. It means like, does it mean that you support it as a client? Does it mean that you support a DHCP server and you have to include the server? Or does it mean that you support relaying those options or some combination of the above?
So
like I said,
you would say it needs to be clearer so that it actually is 8106.
Oh, I don't object to the current text, but the people who wanted that text probably would if they knew what it said, if they understood it.
That's fine. Thanks. I guess that's it. So I put you ahead of schedule, Fred.
Thank you. So let me ask, I've got 20 minutes till the top of the hour. Does that work for you? Okay, then let's do your talk.
Hi, everyone. My name is David Skenazy. I work at Apple, and I'm going to talk about an update to our C6555, which we've, since last time, decided to call Happy Eyeballs version 2. So, excuse me. I'm going to start off by doing a very quick recap of the presentation from last time, for those of you who weren't there, and the general idea of the document, which is the differences between our C6555 and the current version 2. And then I'm going to discuss what we added since Chicago, which are 2 new sections, one on the most widely known transition mechanism that is visible to host NAT64 DNS64, and another one on the limitations, i.e. the problems that Happy Eyeballs do not solve. And we'll finish on next steps for this document. So one of the main differences between Happy Eyeballs v1 and v2 is the asynchronicity of DNS. In the original document, it never really discussed DNS. It just assumed that you had results. And one of the ways it says you could do that was to use getOutterInfo. Except what getOutterInfo does, in C, it's a synchronous blocking call that sends out an A query, a quad A query, they're separate packets, and waits for both replies. And if you get, as you can see here, the quad A really quickly, but the A is out to lunch, you can just be sitting there for a very long time before you actually start sending TCP SYNs. And that's just not efficient. So what the new document proposes is to instead fire off your queries when you get the reply. So you don't need to kind of unify as a bottleneck. When you get your quad A response, you can start the TCP for IPv6, and when you get your A response, you could, if you wanted, start the TCP SYN for IPv4. So the specific algorithm looks a little bit more like this. So since we want to prefer IPv6, when you get the quad A response, you start IPv6 SYN immediately. And when you get the A synchronously later, you add it to the list of addresses. And so then it involves the timers that we were discussing a little earlier today, like 300 milliseconds or so. One of the things we observed operationally is that even if you send the quad A query first and the A query back to back right after it, they very often get reordered, either reordered by the network or probably just by threading on one of the DNS recursing resolvers or authoritative servers. So you can very often end up with the A query coming back like 1 or 2 milliseconds before the quad A. And when that happens, you still want to prefer IPv6. So what we do in this case, if the A returns first, we have a very short timer, so 50 milliseconds, that just says, let's just wait a little bit to see if the quad A is in the pipe. And if we get the quad A during that time, then we start the v6 and just put the v4 later on the list. If, however, after 50 milliseconds we don't have it, odds are the quad A query or the reply got dropped by the network, so let's not wait a full second for the DNS transmission, let's start the A. And then if you do get the quad A, you add it to the list later on. The list I'm talking about is then sorted. So every time you get a DNS reply, you add things to the list and you sort it using RFC6724. So a bunch of rules. In general, what that means is you put v6 first and a bunch of other different properties based on scope and everything. And that RFC also has provisions to add rules between rule A and rule 9 if you have more data in your operating system. So this document recommends using 2 new rules. One is to leverage RTT information. So if you've connected to these 2 addresses before and you know one is faster, prefer the one that's faster. And if you used one before and you haven't used another, prefer to reuse that address. A lot of the servers out there for things like authentication, so like your TFO cookies or your HTTP cookies, don't necessarily load balance these. So if you hit the same server, you have better odds of reusing a session ticket or something, whereas if you hit a new one, you may have to do the full exchange again. And if you were to just sort all the addresses and you got, let's say, 8 IPv6 addresses and 8 IPv4, you'd end up most often putting all the v6 addresses first and then all the v4. And then if you're waiting, say, 300 milliseconds, that ends up being a lot until the first v4. So then what you do is you grab the first address from the second family, so the first IPv4 address, yank it out, and put it up in the second or third position. That way, you're going to still fall through the v6 ones, but you still hit the v4 in case your v6 is completely busted. The number of v6 addresses doesn't delay you. This is also a slight change from the original Happy Eyeballs RFC, because that one only ever discussed hitting the two first addresses, the first v6 one and the first v4. As it turns out, one of the reasons when you do a DNS query for, say, google.com, one of the reasons they give you a bunch of addresses is that you can fail over between them if one of them happens to be down. So this document recommends going through the entire list until the first one connects. And as we've seen in operational data, 90-something% of the time, the first address is the one that we end up connecting to. So then you don't end up ever touching the other ones. But if that one were to not connect, you keep falling through. In terms of the connection attempts, so when you're walking this list, you have a timer between them. So you don't want it to be the 60-second timer because that would be deadly to the users. But you don't want to start them off at the same time either, because actually sending SYN adds load on the network. In case of IPv4, it can create NAT entries, but even in IPv6, if you have firewalls and whatnot, opening connections creates state, and so you're adding load on the network for no reason. So having a small delay on the order of 100 milliseconds to a second allows you to still fall back in a way that the user won't find unbearable, but still will avoid overloading the network. So what we actually end up doing in our stack, when we have this historical RTT data from previous TCP connections to this either host or similar route, we take the mean of the RTT plus 4 times the variance. A way to think about it is, once you've hit the average of an RTT plus some variance, you should have gotten a SYN-ACK by now. If you haven't gotten a SYN-ACK, something probably got dropped. So that's actually the number that our stack ends up using for TCP SYN retransmissions. So if your SYN, basically if we start off the v6 SYN, and after a while we go, no reply, that's fishy, and we resend the SYN to that address in case it got lost, it's at the same time that we send the SYN for the next address. And that way you can kind of stagger them to avoid putting load, but still react pretty quickly. We also have a lower bound on this, that's 100 milliseconds, because again, you don't want to hit the network too aggressively. So now, time to wake up for those of you that weren't listening because you were here in Chicago. The new section on NAT64 and DNS64. One of the points in the NAT64, I don't remember which, one of the NAT64 and DNS64 RFCs was that it doesn't require changes on hosts. Because the idea was the host would call get_info for this host name, even if it was a v4-only host name, the DNS64 would synthesize and the software would connect to that and everything would just work. Turns out it's not that simple. That works for a lot of cases, so that's still great, but we've noticed there's operationally 3 issues at least that need to be addressed. So the first one is IPv4 literals. Like a user can type in an IPv4 address into their HTTP browser, and you can't just drop that on the floor. They want that to work. So what you do then, you use the discover the NAT64 prefix, so that's documented in RFC 7050, and then you combine that prefix with the v4 address to basically do the DNS64 type operation locally. That's documented in RFC 6052. And that actually works pretty simple and it works really well. We also added an API for this. If you call get_info with the v4 address, it'll do all the work for you on our platforms. Another failure mode that we've observed that is pretty rare but still noticeable enough that people complain loudly is host names that have quality records that are bogus. And I'm not talking like the ones that have completely bogus ones. We've seen quality records of like linked local addresses or things like that.
those you could imagine figuring out that they're wrong. But some of them have quad-A records that look fine, but actually lead to absolute nowhere. My favorite one, I forget for which website it was, someone reported that it didn't work. And what they did is, for the quad-A record, you had the v6 prefix, and let's say their IPv4 address was 1.2.3.4. They had the v6 one, and it ended with 1:2:3:4, which is not 32 bits, that's 64. Someone just typed in the same thing and replaced the dots with colons. Turns out that's not how v6 works. Not much more complicated, but just a little bit. And yeah, anytime you would try to send pings or TCP sends or whatever that address, go nowhere because it was completely bogus, but from the host, you can't really guess that. So what we do in this case is, when we're on a v6 only network, we generally only do quad-A queries because the A queries are wasteful. What are you supposed to do with a v4 address when you have no v4 connectivity? So we do the quad-A query and we try TCP sends to that v6 address. But if after, like, this is a very long timeout. This is like a last resort thing because it's a very small number of websites. And if after 2 seconds you really, like, nothing's working, then we fire off the A record, get a v4 address, and go back to step one as if the user had typed in a v4 literal. Synthesize, like, do quad-A query for IPv4only.ARPA, get the prefix, synthesize the address, and connect. And for those small set of busted websites, that allows the user to, after 2-something seconds, still see the page they're looking for, which makes people happy. A third case is even more subtle, is when you have a VPN that decides it wants to tunnel your DNS traffic. That's actually very common. A bunch of enterprises have their network set up, Apple's this way, for example, where a bunch of websites, something.apple.com, are only accessible through the VPN. So if you try to resolve that on the public DNS, it won't work. But they're not all under the same umbrella. Some of the, like, developer.apple.com is accessible worldwide, but not all of them are. And also, to protect users' privacy, they want to tunnel all the DNS traffic through the VPN. However, it's a split tunnel VPN, meaning that it only routes some portion of the internet, only the internal network. So what ends up happening generally on a dual stack network is you send all your DNS queries to the VPN server. If it's internal or otherwise, it gives you the right reply, and then you can connect to that. The problem is, now imagine you're on a v6 only cellular network, which in the case of our customers using T-Mobile is the case, and you're trying to access a v4 only website. So you send your DNS query to your VPN DNS, and they query up the server and say, oh, well, there's no quad-A record, and here's an A record. And then you look at it and you go, oh, I have an A record, and I don't have a v4 address. Drop it on the floor. What do I do? Because the DNS resolver for the cellular interface, it doesn't know about your internal VPN queries, so it can't answer those. But the VPN resolver doesn't know what the NAT64 prefix on the cellular is. So you end up having, no one actually has the root of truth for how you're supposed to connect to this address. So what you have to end up doing is you do the A query to the VPN, you get it, and then back to the previous step above, you synthesize it locally. At the end of the day, it's not that much work because you basically just plumb all these things into the one above. But it's like small details that we necessarily hadn't thought of when these RCs were initially written or when we wrote our first implementation. It really happened in operational issues going, why the hell isn't this working? So we've added those to the document to help people who are trying to implement this not discover these issues on their own. And quick point, so yeah, we added a limitation section because there are 3 things that Happy Eyeballs do not solve and are considered out of scope of the document. First one is path MTU discovery. So that is a real problem. We're not denying that. However, we believe that that's best solved inside the TCP stack because Happy Eyeballs only operates at the connection time, so SYN, SYNAC, which unlike QUIC aren't padded. So you actually don't notice any MTU problems between the SYN and the SYNAC. So Happy Eyeballs can't really help here. The second one is application layer issues. Those are very, very rare these days, but there are some websites that'll connect at the TCP layer over v6 and then completely fall over because some application layer had code that would expect the address to look like something dot something dot something dot something, and when it doesn't, they just crash. Not that many, but again, Happy Eyeballs can't really help here because once it's connecting, it passes off the connection to higher layers and it doesn't know what's flowing through it. And the third one are just general operational issues of hiding operational issues, really. That if your access network is dual stack and someone unplugged one of the routers to vacuum and you lose all v6 connectivity, Happy Eyeballs will kind of hide that from the customer. But that's kind of the point. So Jordi has a draft that I'm probably presenting later in V6OPS to say, how can we actually address this problem? And I think that's an interesting solution, but it's marked as out of scope for Happy Eyeballs in particular, because the whole point is for users to not have to notice these operational issues. In terms of next steps, so since Chicago, the document was adopted by the working group. We renamed it to be a standards track document that updates and obsoletes RFC 6555, becoming Happy Eyeballs v2. Our implementation is deployed widely to over 1 billion devices at this point. And we're wondering what the next steps are. Are we ready for last call? Do people have more feedback that they want us to address? We're happy to hear more. We welcome questions.
Jordi Palet. Jordi, go ahead.
Thanks for taking this work. I think it's ready for last call, probably. Let's see what others believe. I am not an implementer. I am not a developer of stacks or operating systems. So I understood now that my request for including the PAT-MTU solution is not really a good idea to mix with Happy Eyeballs. But the question for you is, as an implementer, do you think there is some possibility to work on that solution in something that runs in parallel or after Happy Eyeballs? I don't know. I am just...
Yeah, so the way our stack does it is it keeps track of what size MSS it's been sending and what's been ACKed. And if it realizes that at some point when it's got enough data from the application and it's sending full, like 14, 20 or 14 more packets, that those aren't never getting ACKed, it actually has some logic in the TCP stack to dial back the MSS until something starts flowing again. So we have support there. It's completely separate from Happy Eyeballs. I'm not sure that's documented in an IETF document. Maybe it could be. Then it is. So, sorry,
I am not really sure it's documented in such a way that all the operating systems are implementing something to sort it out. So I am willing, if there is other people interested in working on that, and especially people working on stacks like you, to work in a draft to document that and to provide some hints to other operating system or stack developers. So let's talk later if you're interested.
That could be interesting. I think we may want to take it to another working group like TCPM, but
yeah,
thanks.
If you do want to chase that, I'd suggest getting Matt Mathis involved. So, Lorenzo?
Lorenzo Coliti, partly non-technical question here. I think this all makes sense from a technical perspective. A couple of non-technical things are, this is kind of relatively hard to do. So if you're building a $100 billion product, sure, you do everything that you can. The question is, what should we recommend to less sort of sophisticated products? And I think one interesting thing is to characterize the cost benefit of doing this kind of thing. Like, what do you lose in today's internet if you don't do this? And is that getting better or worse? This is not really necessarily related to this, because again, this is just, if you want to do something awesome, go do this, which is great. I do wonder what sort of guidance we'd want to provide. At what level does this become important? And the other side of that is, There are platforms that don't do this. There are platforms that take the approach of like, well, you know, if the network is broken, we're just going to not use V6 on this network at all ever. And I sort of wonder which one we want to recommend in general. And maybe it's just healthy to have a mix of those different approaches so that, you know, I don't know, sort of, because we're going sort of, I forget if this is going to be BCP or informational, but
Standard track. It's the same status as RFC 6555.
Right. I suppose you don't have to implement. So I wonder if, I guess the question that's most useful is, do you have the data that says what you lose if you don't do this, and whether that's getting better or worse? That's.
We do. There's a talk by Tommy Pauly from Alpal as well at MapRG from a few IETFs ago that discusses this.
And could we put some of that in here, or does it make sense to put it?
That's a reasonable ask, yeah.
Okay. Michael Abrams. So I think the comment about PM2D, to actually reference that in that section where you're saying this doesn't solve this, please use that instead, like a direct reference, because then you get that in. We've now had happy eyeballs for quite a few years, and did we get any feedback from like web server operators to say, was this ever a problem? Like, did it increase their load a lot and so on? I mean, now we're increasing the timers, and it shouldn't be a problem anymore, but I don't know, did we ever get any feedback on that, or complaints or something?
I haven't seen any particularly.
Yeah, so I think that's like for the room, if anyone knows, it would be good to, if we're now changing this, and I think we're changing it for the better for the web server operator, but it would still be good if someone has information, or just saying it was never a problem. No, you don't have to ask them.
If you have any data, please reach out, and that might be worth including in the document. Thanks.
Nabil?
Hi, my name is Nabil Ben Amar from University of Meknes, Morocco, and an ISOC fellow here. So my question is about your the timer that you have stated in this RFC, in this draft, which is 15 milliseconds. So based on what you have chosen this timer exactly with this number? Because, for example, for the previous one, it was 300 milliseconds, and there was no clear specification on based on what they have chosen this value. But in the previous presentation, at least we have some statistical data that shows that it should be decreased to 150 milliseconds, and it makes sense. So.
There are two separate timers. One is when you've started a TCP connection, by that I mean sent a TCP SYN, how long do you wait until sending the next one to the other address if you haven't heard back? So that's the one that's based on RTT. That was initially 300 milliseconds in the initial document. That was recommended 150. So that's one timer. The other one is the DNS timer, which is when you get the A record in 50 milliseconds. Both were determined empirically from data we have from our billions of devices in the field. We noticed that 50 milliseconds was a good sweet spot, that it covered like the 99th percentile of cases where the V6 just got reordered and came right after it, and was still small enough that the user wouldn't notice. So that's how this was determined.
Okay, did you mention something related to the basics of this number in your draft?
Yes.
Okay, thank you.
Okay, Dave, and then we'll cut off for the day.
Okay, so Dave Taylor, mine is a comment on Lorenzo's comment, right? Because Lorenzo talked about how there's different variations of things when he's talking about the status, and I think proposed standard is fine. I think the goal in having a standard is, of course, to provide flexibility, right? We had happy eyeballs, now we want happy eyeballs v2. Why? Because you found things that, well, all of us found things that are learnings after happy eyeballs. And so just like when we did 3484 and 6724, there's opportunities for innovation. You know, if you have some better idea, insert row 8.5 here, and everybody did, right? And so there's already variations of things, and as long as there's opportunities for improvements, you don't have to rev the RFC every time you want to innovate and still claim compliance. I think that's what's key, right? Is that sooner or later we're going to want happy eyeballs v3 because we're going to learn things over time, inevitably, as the world changes or whatever. And so as long as the rules are flexible enough for people to have implementation variations along the lines of what Lorenzo said, okay, then as long as it's not too constrained. And so that was the discussion around 6555, which was why it was recast from an exact algorithm and a set of requirements to provide that flexibility. And that's why you can still claim that, yes, you're conforming to 6555, even though you've already shipped happy eyeballs v2, right? And so it's retaining that concept that says we want to allow innovation as we learn things, okay, and still claim compliance. That's what's important when going to proposed standards.
Thanks, definitely agree. Just to make sure I understood you correctly, do you feel that the draft as currently written does this?
I can't answer that right now without going back and looking. And so going to last call is one way of forcing me to do that. But
Great, thanks, because I agree with you, and if it doesn't, please yell.
Yeah.
Right, but our intent is the answer should be yes. And if there isn't, if there's a case where it's not, then we fix that.
Agreed. So question, have you got another revision of this draft coming out of this discussion that we've just had?
I mean, from minor comments, from like adding the reference to PMTUD and things like that, maybe a very minor one, but that's about it.
Okay. So here's what I'm thinking. Let's go ahead and have that revision, and then we'll take that to working group last call.
Sounds good to me.
Okay.
All right. Thanks, everyone.
Where are the blue sheets? So here comes one. Thank you. Well, I've got a lunch planned, but
No, it's today. Yeah, I'll send you an email.
Yeah.